So, ladies and gentlemen, my name is Reynolds Sofa Ekwapon. I'll be your moderator for today. And before we start, we would want to commit the whole conference into the hands of God. So, wherever you're seated, let's share a quick word of prayer. Father, in the name of Jesus, we thank you. We commit today's gathering into your hands. We ask that you take preeminence. We are here to deliberate. We are here to share ideas. We ask that you grant us the grace and wisdom, and at the end of the day, when all is said and done, we'll have a cause to say thank you. We bless your name in Jesus' name. Amen. Right. I had a resounding amen, and that was very good. It tells me that you are here. So, ladies and gentlemen, distinguished guests, fellow innovators, welcome to the Infrastructure for AI conference. And we believe, or you would agree with me, that in a world where artificial intelligence is revolutionizing industries and redefining the fabric of society, the infrastructure that supports AI is just as critical as the technology itself. So today, we gather here as experts, thought leaders, and pioneers to explore the backbone of the AI-driven infrastructure, which must be robust, scalable, and of course, an intelligent infrastructure. So from data centers, which powers machine learning algorithms, to networks enabling seamless collaboration between humans and our machines, AI demands a lot of innovation. It demands resilience, and it demands what? Vision. And I believe that this that is evident is that Africa is a global, or Africa emerges as one continent that is ripe for AI transformation. Right. And having said that, there is one thing that is also evident, that in as much as there is great potential within this African sub-region, there is also a big challenge. Is that I know that as technical or technocrats in this field, you are very much aware of, is the challenge of infrastructure. And that is why we have gathered here. So I believe that for the many concerns that we have, our speakers for today's conference will help us delve deep into it and give us So, you are here, I am here, and I want to take this opportunity to welcome you once again to this AI Infrastructure Conference. I thought you would put your hands together for that. That is not for me, that is for you. Now, this conference has been put together, kind courtesy, the vision of VHF Solutions with its global partner, and that is what? The Simon Group. As time goes on, I'll be informing us or giving us detail of these two powerhouses when it comes to ICT in Ghana and Africa as a whole. Without much ado, we would want to have or welcome our chairman, who is going to steer the affairs of today's conference. We have prayed. We have committed everything into God's hands. But it is important that we also have someone who will lead the affairs and steer the affairs of today's conference. Many of us are from different tech companies. Many of us are from different sectors. Many of us are also from probably policy development institutions. But however, I believe that we all need to come together to share ideas, to be able to shape the course of technology, and to be able to also take advantage of what technology offers us. Because we know that the impact of technology in the various sectors of our lives cannot be underestimated. Now, chairing today's conference is a man who is a consultant on digital transformation. He is the former head of Stanbic Bank Limited engineering team, and he oversaw the digital strategy of the bank and had responsibilities that spanned partnerships and technology, among others. Prior to this, he served as the head of sales and distribution of MTN Ghana. That is a big position. Yes, he's led the process of creating today's mobile money ecosystem and the growing usage of marginal levels of pervasive levels that are evident today. He has worked across management, consulting, manufacturing, and academia. Our chair for today holds a BSc in chemical engineering and also an MBA. He is married and he has 2 daughters. Please help me welcome to the podium our chair, Mr. Eric. Please, Engineer Eric. Yes, let's give it up for him. Let's give it up for him even as he comes. Our chair is going to open the function officially for us. And right after that, we'll delve into the details of today's conference. Please, he is not here. I think you can do better. I think you can do better. You're very welcome, sir.
Thank you. Good morning, ladies and gentlemen. It's always a pleasure to welcome people to the Ghana Institution of Engineers, since I myself was welcomed only now 6 years ago. And I've taken the liberty before the event to at least talk to a few people to identify what interest groups are here. As usual, I will complain after to my good friend, Mr. Arthur Roberts, and say the power people are always dominating the electrical work stream, and we want more and more to talk about software engineering, we want to talk about artificial intelligence, we want to talk about IT. Well, I've looked at the brochures that have been shared and the links to the various infrastructure of CMON and VHF. I am fascinated like everybody else. When I was a chief information officer, this was my daily bread. And it's a role that I think you know how they ask people, what do you do? I'm a lawyer. What do you do? I'm a doctor. I feel like since the age of about 29, it has been, what do you do? I'm a CIO. Because in those days, in the 90s, we were lucky. I look at young people today and I say, well, it takes a bit longer. But in the 90s, you could become a CIO very quickly. There were not enough people to build the IT departments. And as we've journeyed, we've tracked and are happy to see this level of data center infrastructure, networking infrastructure being put up for our consumption in these parts. Artificial intelligence, as you know, is old in itself because it starts with spectral mathematics at the turn of the 19th century. So for those of you who love mathematics, if you have a billion by billion simultaneous equations and you have to solve them, you know that the matrices that will result, you need to be a strong person to be able to take care of that. But that type of stabilization happened in the mathematical innovation of the turn of the century. Recently, I think 2 years ago, when the Nobel Prize was issued to Geoffrey Hinton, the citation contained the history of artificial intelligence. And you would see that they started from the 1940s, the work of Turing. And then they moved on to the 1950s, a landmark seminal article on perceptrons. And beyond that, they started to identify how recursive neural networks were formulated and how convoluted were formulated. And of course, transformers have brought us what we see today, and in GPT-5 and what is going on in BERT and all the auto-encoding and many things that are happening today. We are hoping to be able to deliver vision and audio and all the permutations of the sensory nature of humanity. But intelligence itself is something that I leave for the younger people to reflect on, because biomimicry is what we are seeing, that we are building a lot of technology that can do things similar to life. But intelligence I offer a bit of a higher framework when we are talking about, sentient, conscious type of dimension. So enough of that. I only went into that because I'm looking at the faces of the young people, and I'm trying to make the case to the head of the work stream that people also want to reflect on AI and all the other stuff. So from time to time, we'll deviate from power a bit. Thank you very much for inviting me to look at this. I was waiting for the running order so that I can invite the first speaker. I have a list of speakers, but I would need some guidance from you, Mr. Handel, on who goes first. You come, okay. So welcome again to Roman Ridge, to the DHIA, and we invite Mr. Handel to take us through the running order.
Thank you very much, Mr. Chair. The President of Ghana Institute of Engineering, the Chairman for this occasion, distinguished representatives from CIMON and Arista Network, esteemed engineers and technology professionals, representatives from telecommunication industries, honorable clients from government and private sector institutions, invited guests, ladies and gentlemen. It is my singular honor and privilege to welcome you all to this high-level professional forum titled Connecting Intelligence Infrastructure for AI Era. Your presence here today reflects a shared commitment to advancing engineering excellence and preparing our nation for the next wave of digital transformation. Mr. Chairman, we are gathered here today with a clear and deliberate purpose to examine how infrastructure must evolve to support the artificial intelligence era. This forum brings together engineers, technology leaders, regulators, and institutions to focus on physical and digital foundations that make AI possible. Our objective is to share global best practices, explore emerging technologies, and foster meaningful partnerships that will enable Ghana to design, deploy, and manage infrastructure that is intelligent, secure, resilient, and future-ready. Ultimately, this gathering is about ensuring that Ghana is not merely a consumer of advanced technologies, but an active architect of the digital future. This event is HF Solutions and Consultants Limited in partnership with CIMON, a global leader in structured cabling and data center infrastructure, and supported by Arista Networks, renowned for high-performance, data-driven cloud networking. We created a platform to focus how intelligent infrastructure will power the future of Ghana and Africa. Mr. Chairman, VHF Solutions is a Ghanaian engineering and ICT solutions firm dedicated to design, deploy, and support of intelligent building and digital infrastructure. Our field of expertise spans structured cabling and data center infrastructure design, CCTV surveillance and intelligent video analytics, network management systems and enterprise networking, intruder detection and integrated security platforms, access control and identity management, fire detection and life safety systems, IP telephony and unified communication, and finally, technical design support, BOQs, and project consultancy. Our philosophy is simple: to bridge global technology with local expertise, ensuring that institutions in Ghana receive solutions that meet international standards while responding to our unique operational realities. Mr. Chairman, over the past decades, our industry has witnessed a remarkable journey. Data networks were designed mainly for email, internet browsing, and basic enterprise applications built on 1G and 10G platforms with largely manual management. Today, the industry has moved decisively towards AI, high-speed, and highly automated networks. We now speak of 400G and 800G, Wi-Fi 6, Wi-Fi 7, software-defined networking, and zero trust security architectures. Data centers are being redesigned for GPU and AI workloads, requiring ultra-low latency cabling, intelligent power delivery, and real-time network analytics. What was once a simple transport medium has become an intelligent, programmable digital platform that connects CCTV, access control, Internet of Things, voice, and cloud services into one resilient ecosystem, forming the foundation of smart buildings and global. In the same way, network management system, NMS, have moved from simple monitoring tools to sophisticated platforms that visualize, automate, and secure complex enterprise networks. The next generation of NMS, powered by AI, self-healed, optimize bandwidth dynamically, and provide predictive maintenance long before failures occur. Mr. Chairman, distinguished ladies and gentlemen, none of these innovations can function without solid foundation. At the heart of every smart building, every data center, and every AI platform lies structured cabling and high-performance networking. This is where the expertise of Simon and Arista Networks becomes critical. Simon quality cabling systems provide a physical backbone capable of supporting ultra-high speeds, low latency, and the power demands of GPUs, dense AI environments, whilst Arista, advanced switching and software-driven architectures deliver the intelligence that moves massive data workloads reliably and securely. Together, these technologies forms the nervous system of modern infrastructure, enabling hospitals, universities, banks, airports, and industries to operate efficiently in the age of artificial intelligence. As engineers and technology leaders, we carry a responsibility beyond deploying equipment. We design the platforms that will secure our cities, protect our data, power our industries, and educate the next generation. AI is not a distant concept. It is already reshaping how buildings breathe, how networks think, and how machines collaborate with humans. Ghana must not be a consumer of this revolution alone. We must be architects of it. Mr. Chairman, on this note, I wish to express profound gratitude to the Ghana Institute of Engineering for opening these doors to this engagement, Simon and Arista Networks for sharing global expertise, our clients from government and private institutions, the telecommunications community, every professional present today, and all who have helped to make today possible. Your participation demonstrates that Ghana is ready to embrace infrastructure that is intelligent, resilient, and future-ready. But Mr. Chairman, today marks another step forward, building an ecosystem where cabling networks, security systems, and AI operate as one intelligent fabric. On behalf of VHF Solutions and Consultants Limited, I welcome you once again and wish you fruitful deliberations, meaningful networking, and practical insights that will shape the project you design tomorrow. Ladies and gentlemen, before I conclude, I wish to warmly invite you all participants to the commissioning of our ultramodern office complex, which will take place tomorrow, 6th February 2026 at 10 a.m. This facility reflects our continued commitment to engineering excellence, innovation, and the delivery of world-class technology solutions locally. It will also serve as a center for technical support, including infrastructure design, BOQ development, and the provision of project-specific advisory services. In addition, our executive briefing center will open to all participants for strategic engagement and knowledge exchange without any fee. We will be grateful and be honored to see you in this occasion. Thank you very much.
Thank you very much, Mr. Handel. Right, so he mentioned that Ghana is ready to embrace the future of artificial intelligence. Once again, we welcome all of you to today's conference, and thank you very much for those welcoming words, Mr. Handel. So yes, we have heard from VHF, and Mr. Geoffrey Handel is the CEO and MD for VHF Solutions. And as I said earlier, this program has been put together by the partnership of VHF Solutions and Simon Group. But you can clearly tell that hosting us today is Ghana Institution of Engineering. And I thought you would clap. We want to say a very special thank you. Hello. Yep. So we want to say a very big thank you to the institution for hosting us today. But in our midst are some key personalities that I would want to acknowledge. Yeah. And as the program actually goes on, I will take receipt of the dignitaries that we have in our midst and acknowledge them. For now, we want to acknowledge the presence of Engineer Sophia Tijani. Please, if you're here, can you be on your feet and let's acknowledge her presence. She is the president-elect for the institution. Oh, do it better for her. Do it better for her. We also have in our midst Engineer K.D. Lai, the former chair of the electrical division of the institution. Please, if you're here, let's acknowledge your presence. Engineer K.D. Lai. Please, let's give it up for him. These are the wisdom wells that we draw from. Thank you very much for your service to the institution and for gracing today's conference. Also in our midst today is Engineer Ato Roberts. Please, let's acknowledge Engineer Ato Robert. He is the current chair of the electrical division of the Ghana Institution of Engineering. Yes, thank you very much, sir, for gracing the occasion. So just as we heard from VHF, next to speak to us will be another partner that has helped to put this platform of discourse together. And I'm talking about the Simon Group. Now, speaking to us next is Mr. Prem Rodriguez. And he is the vice president of the IMEA, that is the Indian, Middle East, and Africa region of the Simon Company, a global leader in network infrastructure solutions for data centers and smart buildings. He is a certified RCDD, that is a registered communications and distribution designer, and he has over 25 years of industry expertise. He has held various leadership roles throughout the Middle East and Africa. Since joining the Simon Group in 2010, he has served and he has advanced to become the vice president of sales and marketing of the IMEA region. That is one of the company's most important growth regions. Mr. Prem Rodriguez will be speaking to us. Please, let's receive him, even as he tells us about the history and legacy of the Simon Group. Thank you very much, sir, your audience.
Okay. Yeah, I'm good, thank you. You have the microphone on your list for the video. Thank you to the moderator. Good morning, everyone. This is my first time to Accra and really loving it. Like Jeffrey mentioned, Ghana is ready to embrace the future of technology. And Simon is here to connect you with the world. Thank you so much for this hospitality. Distinguished ladies and gentlemen, my name is Prem Rodriguez. As the moderator said, I'm based in Dubai. I manage the India, Middle East, and Africa. How many of you have heard Simon before? Show of hands. Oh, very few people. How many of you know how young is Simon? Any guesses? How young? Throw a number. 15, 25, and it's really right. We are established in 1903 and we are today 123 years young. Thank you very much. So Simon is led by the Simon family. It's a fifth generation, and this is our CEO, Henry Simon, whom I report to. And they're very passionate technology and quality driven people. And that's what they have trickled it down. That's in our DNA, the technology and the quality. And that's why we are here to share our experiences, share our vision with you in Ghana today. So Simon, like I mentioned, we were established in 1903. We started working with the telecommunication products for AT&T. I think many of you are familiar of AT&T. AT&T is one of the largest ISPs in the world, telecom providers in the world. And even though we are 123 years old today, we are still a very, very flat organization. We are very resourceful, we are agile, and very responsive. I often call ourselves as a 123-year-old startup company because we are really very, very agile and nimble. We try to innovate ourselves. Simon is present almost every part of the world. We are present directly or indirectly in most part of the world today. Over 100 plus countries. We have 40 plus regional offices, and we have 7 manufacturing and warehouse locations, but we have much more. It's a growing, and we are counting this number. And obviously, we have a huge partner network across the world, like VFH Solutions. As I mentioned, Simon is there in the industry for a really long time, and because of this, we probably hold the highest number of patents in the world for structure cabling, 420 something to be more precise. So, and also we serve more than 50% of the global top 500 companies. So we are specified by more than 50% of the top 500 global companies. We are also ISO certified. We are ISO 9001 certified. We are ISO 14001. We are also 45001 certified. So we take our certifications very, very seriously. Like I mentioned, we are passionate about quality and technology. And for that, these are the testimonies. The certifications are the testimonials. Whilst we manufacture, we are very, very keen on the environment. We believe in a vision to be sustainable. When the world was thinking of going green, Simon was already green many, many years back. When the world was thinking of being carbon neutral, Simon was actually minus 179% carbon negative. So which is very, very rare for many of the organizations. None of our competitors, I believe, have this minus 179%. We are very, very committed. We have a sustainability pledge, and we are governed by ESG. ESG is a new norm called. This is to comply to the environmental, social, and governance. Environmental, obviously, the carbon footprint, the carbon neutrality, net zero matters a lot. Then we also have social responsibility. We do a lot of social charitable events across the world. That's our pledge as well. And governance, how we do business matters a lot to us. We do business with ethics. We do business for not just for profit, but in the right way. The profitability has to be very, very right to us. So in terms of our ongoing commitment, we try to reduce our carbon footprint. We minimize all forms of waste. We try to eliminate pollution or reduce pollution as best as we can. And because of this, we are acknowledged by EcoVadis as a gold member. And also we have been awarded by SEAL as one of the leading companies, true to our commitment to the sustainability pledge. Also, we are engaged. I mean, these are only 3 which we have mentioned, but we are part of many, many standard committees or organizations who safeguard these industry standards. For example, we are a part of Ethernet Alliance. We are sitting on many, many working groups. Many of our engineers are part of these working groups where we try to actively engage ourselves for all the upcoming technology. InfiniBand, it's getting very, very popular now because of the spike and the acceleration of artificial intelligence. InfiniBand also, we are very, very actively engaged and participating. IEEE, I think many of you are engineers, electrical engineers here. I think IEEE is a very, very common group which you might know. We are also a part of many of those working groups in IEEE as well. Alongside, we are a partner with Arista. Arista is a co-host here, and they are going to have a session later in the day. They're going to talk about a lot of their technology, which is unique. We are partnered with them globally, and Arista uses our technology to complement with their switches, servers, just to give an advantage for all the end users and customers we engage with. Cisco, I think it's a very common name. We are also a technology developer partner with Cisco. NVIDIA, this is a new name in the last 24 months. It has become so popular because of artificial intelligence. So we work with NVIDIA. We are a solution consultant for NVIDIA. We design products for their data centers. So we have deployed a couple of data centers. I mean, the recent one is in New York, in a place called Buffalo. There's a data center called TeraWulf. We have worked with Arista there. So this needs very, very good expertise, and that is what CMON carries. So we have worked with NVIDIA to develop solutions for the artificial intelligent data centers. And those artificial intelligent data centers are big power guzzlers. So usually we were talking about megawatts in data centers. Now, because of AI, it's all in gigawatts. So we can imagine the difference. The gigawatt is probably, electrifying an entire city. Now we are talking about gigawatts only for a small footprint of a data center. So we are engaged heavily with this. Our team has the knowledge, so we can pass on that knowledge to any of your projects, any of the challenges that you're facing on a local level. Like I mentioned earlier, we are serving a lot of customers across the world. We're talking about Amazon, DXC, IBM, Deloitte, HSBC. Globally, wherever you see HSBC banks, CMON is the one behind their infrastructure. And many, many companies like this, Barclays, Credit Suisse, Johnson & Johnson. So we have huge reference projects globally. Plus, my colleague, our regional director, Siva, is going to cover what we have deployed in Ghana for the last couple of years in the next segment. So here we are. I would like to say that CMON can support all your needs of data centers, smart buildings, or LAN applications. We don't want to just be called as a manufacturer or a supplier. We want to be called as your partner. So we want to try to be engaging with you at a very, very early stage so that we can add value in your design. The design which will be applicable for the next 25 years. We warranty our products for the next 25 years. So we want to be engaged early. We want to be working with you like a partner, not like a supplier. So with this, I would like to end my short session. I'll be around throughout the day. I'll be happy to meet each one of you. And thank you very much for today. Thank you.
Thank you very much, Rodriguez. Now we see that indeed Simon is doing great in Africa. Right. And looking at the work that they have actually accomplished across the globe, we would want to actually want to know more about what its presence in Africa looks like. And that is what the next speaker is going to focus on. The next speaker is a seasoned sales leader with over 24 years of experience in IT infrastructure and connectivity solutions industry. He works closely with enterprise customers, that is data centers, operators, colocation providers, and managed service providers, enabling scalable and future-ready solutions for data centers and smart buildings. Because of time, let me jump a bit. Our next speaker holds an MBA with first class from Cardiff Metropolitan University. He is currently pursuing a doctorate in management, applied business leadership and research, that is in Spain. And he also holds an MPhil in applied business leadership and management. I am talking about no other person than Siva. Siva will focus on the presence of Simon in Africa. Please, let's do it better for Siva.
Morning. First of all, thank you very, very much. I see a lot of pleasant and happy faces today, so very good. And so it gives me, the entire team, the Simon team, Jeff, the Arista team, a lot of pleasure to welcome your distinguished guests here. So I'm not going to take a lot of your time, but very few people in the beginning knew what Simon was. But after the end of the day today, we want you to carry on forward what knowledge and expertise we want to share with you. And presently, we are involved in a lot of projects in Africa, and this is what I want to talk to you about today. It's not just Ghana, me and my team. Oh, and by the way, I am supported by an able team. So here with me, I have Mr. Adewale Olagbendro. Adewale, if you want to please. Yeah, Mr. Ade is based in Nigeria, so any of you who want local support, where Mr. Prem explained where you need design expertise, please do engage Adewale as your first point of contact. And probably the key person today after me is going to be a gentleman who is going to be talking a lot of technical jargon, and he's just sitting quietly in the front, and he is doing a lot of groundwork, and he's been involved since morning setting up this whole thing. Mr. Dinesh OP, would you please make yourself available? So he is going to be doing a lot of key groundbreaking topics on smart buildings and data centers. So the next few slides, I just want to talk about what we are doing in the industry today. So the three segments of business that the Simon company focuses are data centers, smart buildings, and enterprise LAN. So distinguished engineers, if you are involved in any data center or a smart building or an enterprise LAN project where you need solid infrastructure support on cabling, I request you with all humility, please use Simon as your first point of contact. Ourselves, along with our distinguished partner, Mr. Jeffrey Handel, will be able to support your requirements. So a couple of clientele across West Africa. The biggest reference today, and I don't know whether all of you know, our biggest customer today in Ghana is the Bank of Ghana. We have deployed the biggest smart building infrastructure along with 2 data centers that they have, the new headquarters. Jeff, how far is this from here? It's probably across the road. Yeah, I wouldn't know the location, but the new headquarters here, the Bank of Ghana, has a Simon solution deployed, and it's the state-of-art structured cabling over there. The Nigerian Stock Exchange, the main one data center, which is now Equinix, both in Nigeria and probably Ghana is also talking to us. MTN Ghana, they have deployed, I don't know whether you all know, they have deployed the state-of-art 100 gig fiber optic networking solution. Anybody who wants to visit MTN, I suggest you reach out to Adivale. He can probably show you some of the sites, installations that we've done. Obviously, some of the banks, Ghana Civil Aviation Authority, the airport authority, works on a CMON cabling infrastructure. We've done a lot of key hospitals here run by the government. And obviously, the references speak for yourself. Ghana Twifor Hospital, Stanbic Bank Ghana, EcoBank Ghana, two of our biggest customers here already, running on CMON infrastructure solutions. So that slide speaks for itself. The plethora of all the clients we have really shows testament to what they want to go with. I mean, obviously, we all realize that CMON cabling is the first layer of any infrastructure design. So if you don't get that right, you don't have anything right. And all the clients who invested with us know the value of a CMON cabling system. That's West Africa. The East Africa clients, I mean, that's our biggest market share by date today. So there you go. So all the references here you see are across Kenya, Uganda, Tanzania, Ethiopia, Rwanda, Burundi, and Djibouti. So all the five big giants in East African countries work with CMON. So that's the huge reference you have. Two of the biggest airlines, Kenya Airways and Ethiopian Airlines, are our biggest clients as well. Their enterprise lands and their data center builds are with CMON. And also, I would like to emphasize, you might be all talking, I mean, today is a cabling day. We're talking about cabling and AI, but Arista here also is going to be working with us hand in hand on designs. So if you have any projects that you want to design, please work with us jointly as a team. We can also pull in other complementary manufacturers here to bring some design support on power and cooling. Although that's our expertise, we can put you in the right direction so that you can get the whole infrastructure built in the right way. The rest of Africa clientele, again, we have clients all over North Africa and South Africa. I mean, this is just a snapshot. I mean, I could go on slides and slides, but for the sake of time, we're keeping this very specific. So there's a whole list of clients that we do in North and South Africa. We're doing it in Egypt and South Africa. So obviously, we are here across the day if you guys need any support on CMON. And why CMON? I mean, that's our global footprint. We have express delivery times on products. Jeff here can support you on lead times with product availability. And as Prem said, we have about stocking locations all over the world where your demand and supply can be met. We understand data centers, we understand enterprise lands, and we have excellent on-ground support to support your infrastructure needs and deployments. So distinguished engineers, if you are working on projects, please do support us, and we can in turn help you with the designs. So that's it from me. I would like to, again, thank you for your well-spent time today. Please feel free to interact with us over the day. We are more than happy to support you and answer any of your questions. And really appreciate your time. Thank you.
Thank you, Siva. Indeed, he said he was going to make it snappy, and he did. Let's give it up for him once again. So now we have a fair idea of what CMON does and what CMON also is doing in Africa, and especially even in Ghana. I believe that even as you said, there are certain questions that you are noting down, or there are certain things that you would want to probably find out in details. Just as the speakers keep saying, this platform is a platform where we exchange ideas, we share. So it is not just going to be you sitting down listening to people talking all day. We are going to have a session where we are going to interact. You ask your questions, and then probably you want to know more and delve deep into the work, or maybe you have something wonderful that you want to share with all of us. So there will be time for that as well. But next to speak to us is Mr. Dinesh O.P. He is the Technical Manager, Africa, at the CMON Company, a global leader in network infrastructure solutions for data centers, smart buildings, and LAN environments. With over 25 years of experience in the ICT industry, Dinesh brings deep technical expertise and strategic acumen to his role. He leads CMON's technical initiatives across Africa, providing consulting services, pre-sales support, project evaluation and implementation, along with conducting seminars and certified installer training for partners across the continent, like we're having today. His leadership has been pivotal in advancing infrastructure standards across diverse African markets. He has led roles in Qatar, Kuwait, India, Kenya, Nigeria, bringing with him a wealth of international experience. He holds several industry certifications, including BICSI, RCDD, DCDC, and OSP, and is a certified accredited tier designer by the Uptime Institute. Academically, he holds a master's degree in data center leadership and management from the ARU UK, an MPhil from UCAM in Spain, and is currently pursuing a doctorate degree. This is a man with worth of experience. He will be taking us through you heard it from the previous speaker. This session is going to be technical, and I believe that this is where most of us are interested. Yes, so we're going to take time, delve deep. If you have questions, please, you note them down. We're going to have the question and answer session after this, and right after this, we'll be going for a coffee break, after which we'll continue the presentation. Ladies and gentlemen, invited guests, please help me welcome to the podium Mr. Dinesh O.P.
Thank you. The study reveals that it's a human tendency, if anyone listening more than 3 hours and the rest of all is discounted, it won't enter their heads. So those who came early, they are lucky. You still have just 1 hour remaining to complete your 3 hours. Who came just now late, you are also lucky to hear my session. So in both cases, all of you lucky to hear. More than that, I am the lucky one to present to you the technical session. Today's technical session on 2 sections, which is intelligent building and the data center. Don't wait till the end to ask questions. You can ask questions anytime, stop me, and then ask questions so that I no need to go back in front of the slides to explain those things. I want you to take home at least some knowledge on IT industry. So before I start, I want to know how many of you seen these cables? Yes, okay. This is category 6A cable. Do you know the bandwidth of this cable? What is the bandwidth? How many megahertz this can support? Okay, it's 500 megahertz. So the difference between the speed and the bandwidth is, I will explain you maybe in the data center side. Maybe I can give you some kind of things, how the data transmits. I want to know whether you want to hear more of jargons like AI and the buzzwords, industry buzzwords like a generative AI and all those things, the marketing words, or you want to really know the technical things, how it works, how the connectivity goes in deep, the technical one. Which one you prefer to have? All are technical. I love that one. I love the people, the technical one. So today I will do a little bit of to make the front benches happy, the marketing touch, and then I will go into the back benches, the technical one, the standard updates and smart buildings, and then the how do we connect. The last one is to make the front benchers happy. But anyway, let's look at the standards update. So how many of you read the ISO standards or TIA standards or IEEE standards with respect to the IT? Like TIA 942 or any of those things. Have you ever read those standards? Yeah, I know, but anybody else in the room read those standards? Just to give you an update, the standards is mainly It is not a regulatory compliance. I mean, you must follow the standards. Standards is not like that. It is the best practice in the industry, all the standards. If you do not follow the standards, you are not legally punishable. The codes and the regulations and the international codes are, you must comply to that one, but the standards is not legally punishable, but it is good to have. It's nice to have so that it will stay for longer, especially for the cabling, the life cycle of the cabling system. It is like 10 to 15 years. Even though Simon gives like 25 years warranty for these cables, it will carry 25 years of warranty, but the life cycle is maybe 10 to 15 years. Building life cycles is like 30 years. I don't know, this building might be 30 years old or more than that. But the cabling, you can change every 10 years or 15 years. Mainly we look into the standards for, especially for the connectivity on IT, is TIA, which is North America specific. It has a specific standards. By the way, I have some gifts. I may ask some questions, so it's good to know that one, what I'm saying, so that if you answer it, then you will get some fantastic gifts over there. Some of the things is, if you look at those 568 generic cabling system, the standard, and there is a series of that one, 569, 606, 607, all those things. Some of them like pathway spaces, administration means it's a labeling standard. You might be thinking, what standard do you need to put a label on these outlets or the face plates? You know, the data outlet, you put a D1, D2, D3, D4. There is a standard. You cannot put like whatever you know, you just write it. No, follow the standard and put those stickers over there. Yesterday I visited the parliament, the Ghana parliament. The one thing I liked it over there, all the rooms are labeled. It's so properly labeled. That is how it's supposed to be. Including the rooms, faceplates, outlets, pathways, everything has to be labeled. If you want to do that one, you can refer to the standard 607. No, not 607, sorry, 606, administration label. These are all the common standards, and we have premise standard. For example, if you are building a data center, there is a standard for 942. 942, the latest standard for 942 is 942C. Last year, mid of last year is standardized. Before it was, we were following 942B. If it is an industrial or healthcare education system, there is a specific standard for each and every building, what you are building it. You must look into those standards when you are doing it. And finally, there is a components. The components means these connectors and cables. What are the things it has to be, how it's supposed to be, the cables. The performance of the cable, fiber cable, copper cable, and then coaxial cable, or the single pair Ethernet. I will talk about the single pair Ethernet, interesting one, which is coming up in smart building spaces. And there are under development. Very soon we will be seeing multi-drop single pair and industrial single pair. It might be, you might be thinking what this guy is talking. I don't know all these things. We'll go deep in that one. Okay, don't worry about that. What is single pair? I will explain you for those who is newborn people in it. There's a standard now. The TIA committee, they are combining intelligent building and generic cabling into the commercial, because it's all the three falls into the same category. So if you are specifying any of the tender document, the technical specification, you might be think of that one. Do not use that 568.0 requirement in it, because it very soon, this year, it will be obsolete and the new standard will come. So this is TIA, which is North America specific, and there is ISO is there. If you are following ISO in the project, ISO 11801-1, that is the 11801, that is the standard for structured cabling. Everything talks about that one, generic one, and then they do have the premise, data center, intelligent building, all the standards are there. That is the building standards, and then the operation standards, which is grounding and bonding, and how to install it, how to install these cables. It's not just pull a cable is a cable, just pull it and connect it, it works. No, it's not like that. You have to follow certain procedures to install it. That one will defined in these standards. And then how to test it. After installation, you have to test these cables. So there's a standard for that one. So TIA, ISO, now it is IEEE. IEEE mainly, there is a project 802. It's called project 802. Have you heard about 802.11b/g/n or something like that IEEE standards? So the project 802 talks about Ethernet, the connectivity, how it is connecting. Most of the times it is used in the active devices side, but these things will connect to those endpoints. That is what IEEE is talking about. So mainly for passive network, two things, ISO and TIA is very common. And for active electronics, it is IEEE is very common use. So these are the two things. As Prem mentioned, Simon V actively participates in all of these industries, including the InfiniBand, Ethernet Alliance, ISO, TIA, and even IEEE. That is the TSG group, Technical Service Group, where I am in. So we participate in actively contributing to all the standards and update. Not sure in 2023, when I did a conference here in Ghana, I showed this slide at that time. And I was telling that in next 5 to 10 years, we can expect like 400 gig connectivity, the speed, 400 gig speed, we can get it on the data center or even in your server to the switch, 400 gig. That is in 2023. Now 3 years later, you know where we are now. When I was telling this one, like 50 gig on copper or Wi-Fi 7 is expected 5 to 10 years later. But we didn't wait till 5 to 10 years. Now we are in there, 400 gig already in the market is there. So we are in now 1.6 tera. We are talking about not 400 gig. We passed 800 and back in our kitchen, we are already cooking 1.6 tera connectivity. We already in there. This year is going to release. Next couple of months, 800 gig, 1.6 tera. 800 gig is already there. 1.6 tera will be in. That is the speed, what we are looking at. Wi-Fi 7 is already there. And now Wi-Fi 8 is looking at how best it can be done. So the IT industry is so fast. It is, if you are away for like 5 months out from this place, you will be pushed back like 10 years. That is how the IT industry is. In my whole career, 25 years of career, I went away from IT industry for like 1 year. I went away and then came back to IT industry. Then I have to start like 3 years back because everything is changed. Every day it is changing. So when we talk about what's changing, the smart building is getting into huge things going on in the smart building. You know, everything is connected devices. So it started early 90s, 1995 when the data network. How many of you seen the coaxial cable connected to a PC? How many of you seen a x86 machine, 086 machine? We are in the same boat. I started my career those times. When 86, when I was studying, first time I touched a computer, 086 machine with 512 MB RAM. 512 MB RAM. Wow, they were saying 512 MB RAM. It's so good with a floppy disk. That is when 1996, when the Ethernet started, these cables started. Gradually, every item is putting on it. The lights, even the projector, cameras, access control, TV screens, everything is now on this cable. Sorry, if you are an electrical engineer, I'm not saying that your job is stealing IT guys, but that is where the industry is going towards. If you see any office, whatever you are seeing, the electrical items, everything will be running on this cable. The projector, or if you have a TV, you have a desktop. Desktop doesn't need a power socket, UPS socket. It just needs this cable to power the desktop. The ceiling fan, it can be on this cable, running on this cable. There is a PoE ceiling fan is there. Everything will run except the lift or the ACs. which need high power. So the advantage of running everything on this cable is reduce the OPEX and increase the user experience, making people more lazy. You can just switch off the light here instead of getting up there and then switching off, I'll tell you a story. One of my friend was telling, he went to BBC in 80s. The BBC, British Broadcast Corporation, they were not using a networking in their system. They are using the desktops and then use the floppy, copy it, and then give it to him and copy the file over there. The guy said, we can do the networking, we can connect it, so you want to send a file, you just send it, he will receive it. The IT guy saying, no, I don't want that one. Said, why? It's easy. No, now if I copy a file on a floppy, I go to him, I give it to him, and I can have a short talk to him, have a coffee with him, and then I come back. If I have a network, I can't see him, I just send him. We will lose that connections. So that is how the things are going, but you have to go with the flow. You can't disconnect from them. Can you imagine? Have you ever tried a no electronics day in your life? Don't touch the electronics for the whole day. Have you tried it? That's a good one. You tried it. We do it once in a month in my house. 12 hours we don't touch any electronics. Once in a month. My kids, my wife, and myself. Only thing, when the phone rings, we pick. We are allowed to pick if it is an emergency. Other than that, if buzz or message comes, no. 12 hours, morning 8 till evening 8. Then we will realize how much time do we have in a life. So much time. We have time to play, we have time to talk, so much time. Try, go back and try. Electronics free day, 12 hours. Yeah, don't sleep, 12 hours, okay, night 8 till morning 8, I will do electronics free. No, not that one. So, all these electronics or IT, IoT devices coming into the building, these things, the Ethernet need 4 pairs. Okay, these 4 pairs required to connect a device to IP. If I have a sensor, assume I have a small sensor which is a thermostat or temperature sensor. That doesn't need like a 40 gig speed. It doesn't need like 10 gig speed. It just sends a couple of points. So you need a small speed, you don't need a high speed. So why do we need all these 4 pair? I can use a single pair. One of this pair, I just connect one of this pair and then connect a device. That is when the single pair Ethernet standardized. How many of you worked on BMS? Or how many of you know SCADA? That protocol SCADA or LANTalk or Modbus, right? These are all the one uses different protocol, not internet protocol. It need a different device identifier, like a neuron ID or something like that. So you can't put an IP address, you need a router to convert the entire link. So that is why the single pair Ethernet comes. One pair you run it, connect a device on the other end and put an IP address there. It's called 802.3BU. It can go 15 meter in automobile industries, in the car, it can go up to 15 meters. So inside the car, all the sensors, the car, do you know which protocol the car communication uses inside the car? The sensor, wiper sensor or the light sensors and all. Which protocol does it uses to communicate? It's not internet protocol, it's not Modbus, it's not LANTalk. Do you know which protocol it uses? I have a gift for those who can answer it. LiDAR for the detection of the things. The communication inside, like if you have a sensor, like a temperature sensor, how it communicate to the controller, MCUs? It's not LiDAR. There is a cable and it uses a protocol. Okay, that gift is for me. I will take it. Jeff, I will take that one. Okay, one is for me. Reserve it. It is called CAN, Closed Area Network. CAN protocol it uses. Okay, so replacing that one with IP We can go with that 15 meters, industrial 40 meters, enterprise 100 meters, and building automation, it can go 1 kilometer. You can run a 18 AWG cable 1 kilometer away, put a CCTV camera, power it on, get the data on the copper. You no need a fiber cable for 1 kilometer away with single pair Ethernet. That is one of the interesting thing happening in smart building. And the next one is, at least not everything, 50% of these connectors, you are aware of it, right? You have seen in your life 50% of it. What if everything we replaced with one connector, RJ45? That is when the AV system came. We struggled a lot of time this morning to connect this HDMI to the projector. So instead of that one, we just need a RJ45 connected there, you just make it. It's called SDVOE, Software Defined Video over Ethernet. So you no need to have a metric switcher. If you go into that room, you will see a metric switcher where you can switch the feeds and you can switch the audio, video, many input, many output, you can do that one. Everything we can do it from the software defined. Just need a Arista switch over there and a CMON cable, nothing else you need. And then connect it, projectors or a display system, everything you can connect with this one. All the wires you can take it away from it. And the next interesting fact is Wi-Fi. Wi-Fi, it used to be the B/G/N. Have you heard that one? B/G/N, 802.11 B/G/N. When iPhone 4 or 5 released, they were marketing the Wi-Fi is B/G/N, which is those things. Now, because the common man doesn't understand all these IEEE numbers, the name has changed. Wi-Fi 3, Wi-Fi 4, Wi-Fi 5, Wi-Fi 6, and Wi-Fi 7. Wi-Fi 7 is also there now. The good example for Wi-Fi 7, which gives more than 20 gig throughput on wireless connections, especially all the mobile phones nowadays comes with Wi-Fi 6 and Wi-Fi 7. And your access point is Wi-Fi 3. You will get very slow speed, right? There was a time my dad lost his phone. He's an old school boy. He lost his phone, and then we were trying to get a phone for him, which he uses only the incoming call and see the text message. He just need that one. We could not get a new phone in India for that one. The minimum you are getting is 5G. We just need a number pad with a call attend, and he doesn't know the touch and everything. That is what happens. Next 2-3 years down the line, I don't think Arista is selling Wi-Fi 2, 3, 4. Minimum you are getting from Arista is Wi-Fi 6. 6 EE and 7, yeah. Oh, this is a new thing for me. The 6 is also end of life, and the only thing you are getting is Wi-Fi 7. So when you are doing the cabling for Wi-Fi, you are designing a wireless access point, cabling for Wi-Fi. If you see the Arista, which is 460, I hope it is not end of life very soon. It's there. Yeah, the 460 or 460E, if you notice that the data sheet of that one, it has 2 ports, LAN ports, not one. 2 of this cable you have to connect it. Please, if you are running a Wi-Fi design, you are doing it, run 2 cables for Wi-Fi. Don't run a single cable. Minimum 2, and minimum, look at that, the category 6A recommended. Minimum Cat 6A you have to run. And these cables, if you are going with this cable, when you are in the break, you can come and see these cables. I was looking for this cable, and in 2023, when I came here, I visited not our partner. On the way, I went to one of the partner place. One person is pulling this cable for Wi-Fi, and I looked at it. The box is written CCA in a big letter, and they are promoting as a good cable with CCA cable. What is CCA cable? Have you heard about CCA cable? It is copper cladded aluminum cable. So the cable, the wire is aluminum, and they paint a copper on top of it. Copper cladded aluminum. It is the best place for this one, even I don't have a space in my dustbin to throw this one. It is so worst cable, never ever use this one. If you see any CCA cables, straight away, throw it out. Do not accept it. It's very cheap. Do not accept it. You will end up with lot of problems. So coming back to the Wi-Fi, that is the one they are using the Wi-Fi 2023. I said, best of luck. I have to go and see those guys, how their Wi-Fi is doing now. And next one is the MPTL, Modular Plug Terminated Link. Because we have lot of devices in the building, every sensors, so many devices in the building. You remember the standard says you must terminate it in a faceplate and a connector and put a patch cord to the device, right? That is how the design is supposed to be. Standard said we have so many devices, you can connect directly with the RJ45, crimp it and connect it. That is when it came with Z-plug, the Siemens Z-plug, which is a RJ45, you run this cable directly, crimp it and connect it. There's a problem. The roadside shop sells the RJ45, crimping RJ45, it is category 5E rated, and it is not rated for this solid cable, it is rated for standard cable. The performance will be degraded heavily. Do not use that one. This RJ45 is category 6A rated and it can be re-terminated. If you want to know more about that one, it is another 1 hour class. I don't have that much time to explain all these things because the 3 hour window, what I have, earlier I said, it's going to end very soon. So, next, the power over Ethernet. PoE, we know the IP phones and door phones and contacts and all. Now we have HDBaseT. That is 100 watts of power. You are all electrical engineers. How many electrical engineers we have in the room? All? How many electrical engineers? Oh, I thought most of them are electrical. You have mechanical and other engineers, right? Okay, those electrical engineers, you know the watts, right? 100 watts means is a huge power. 100 watts can power this projector. 100 watts can power your desktop. 100 watts can do so many things. So when we do the 100 watts powering on this 26 AWG cable, how many of you know AWG means? American wire gauge. AWG, which is inverse, like if it is 24 means it's smaller, 6 AWG means it's bigger, is inversely proportional to those numbers. So this 26 AWG cable, when we are running 100 watts, we will have some issues on these connectors. These connectors, what you are seeing here, inside these connectors, there are like 8 pins are there. Those 8 pins are real gold, by the way. It is real gold, 24 karat gold, hard pressed over nickel. So it is real gold. If you see anything, do not throw this one. You are holding a gold, 24 karat gold. Okay. That is sure, 100% sure it is. For Simon I know, 100% sure. I don't know others. But this one is guaranteed, is gold. 100% gold, 24 karat. And that gold, over the period of time, it will get rusted. It's because of arcing. How the arc will happen? When we connect a RJ45 to here, right? The switch is so intelligent. Switch is not powering 100 watts to the device. It will check, wait for the device. Okay, how much power do you need? 100 watts. Okay, then take the 100 watts. But switch is so stupid, it doesn't know when a user removes it. When the user removes the cable, of course there will be an arc. 100 watts. 100 watts means 1 ampere current on every pair. 4 amps of current. You are removing it, there will be an arc. That arc will damage, oh, I can't show it from here, maybe I'll show you here. You can see here, there is a damage happens over there, right? And the final contact, this RJ45, it will pass through this way. So there will be a damaged port over there. How Simon can give 25 years warranty? we can't avoid that arcing, the damage. It's physics, it happens. We tested in our lab, 100% it happens, but we can avoid, only the way we can avoid in this connector is, we have something called a crown. So the final contact, always you will see the 100% gold contact will be going there. 100% on the gold contact will give you always better performance. We have seen so many people, so many projects, they are asking, keep on replacing these connectors because it's getting burnt every time. It could not sustain the power, 100 watts power. So this is one of the issue in the PoE. And there is a testing methods are there, the compliance IEC 6512. It has to comply to that one for this PoE arcing. The second issue is what we have is bundling. When you bundle these cables, when you have a high current is running on a cable, the cable get heated up. The copper wire will get heated up. So you need to increase the gauge. When you increase the gauge, the cost will increase. Already copper price is increasing. You can't do it just because of the heat. So the only way you can divide the heat, divide the bundles into smaller bundles and break it into the more smaller bundle. What standard states is, they don't specify 24 cables you can bundle, 50 cables you can bundle. No, they don't specify it. They refer to the manufacturer's bundling guideline. Simon released a bundling guideline. You have to refer to this one when you are bundling the data cable. Do not bundle as it is like that. You have to refer to the manufacturers. Now, one more question for the gift, not the front benchers. This cable, what is the maximum distance I can run these cables? Who lift the hand first, they will get it. 90 meter, good. Permanent link or channel link? Perfect. You attended my training, that's why you know that one. Can I have one gift for him, please? Siva, you just give him. Yeah. So these cables, from the cabinet, from the switch, it can go up to 100 meter channel link to the device. That is the longest distance you can run these cables, the data cables, the maximum distance. Unlike electrical cable, you increase the thickness and then run it longer. No, it has a limitation. So because of the heat rise, when the heat rises, the copper resistance value of copper increases. You cannot run 100 meter. You have to derate the length up to 18 meter. You can't go 100 meter if it is a UTP cable. And if it is a shielded cable, you can go up to 93 meter, 7 meter you have to derate. But when it comes to Simon cable, it can go up to 97 meter. And the category 7A cable or category 7 cable can go 100 meter. That is just because all our cables are rated for 75 degree. Most of the manufacturer, their cable rated for 60 degree. That is why we can run up to like 100 meter without any derating. That is the quality what we have. So these are all the smart building things, and then I just want to come into something which is interesting. Recently we came up with something for intelligent smart building initiative in Simon. Is called Smart Building Complete. The solution is complete. That complete is data, power, reach and delivered. These are the 4 major focus for smart buildings. The first one is the performance, the highest performing connectivity for up to like 40 gig or 10 gig and even 40 gig on copper with category 8. That is the data connectivity. And as I mentioned, the power, PoE, power over Ethernet up to 100 watts without any issues of arcing or the temperature rising. Supporting 100 watts on a category 6A cable. And we mentioned that 100 meter is the longest reach, but we have an extended reach. You can run this cable like 200 meters plus, and still you can get like 10 Mbps connections, 10 or 100 Mbps or 1 gig connections, 150 meter. If you have a camera like a 150 meter away, You can use this cable, connect it, it works. So, just for your information, the 100-meter distance limitation is set by TIA standard, not ISO standard. So the difference between TIA and ISO standard, ISO is a global standard, it's not a regional. TIA took the ISO standard and customized to American. So same like Ghana, you have a standard which you derive from ISO standard, you customize to Ghana. Same way TIA is customized to them. So ISO want to look into the entire world, they don't limit the distance. They limit based on the performance. This is the performance. Americans, they limited the distance 100-meter maximum. I'll stop it there. Why? Any idea why they said 100-meter is the maximum limit? It is because in US, they pay technicians per hour. In some of these region, even in some of the places I have seen, they don't pay to the technician at all. But yeah, we don't pay per hour, it is per month. But yeah, this is how it works. So we can go beyond 100 meter. These cables can go beyond 100 meter and still you can get the warranty for that one. It will work. So save some cost, adding additional floor, these things. And the final one is delivered. Delivered means the solution what we give, the add-ons like the design services. We have some tools available for partners online. Partner portal, we have so many Wi-Fi tools and selection tools, many things we have, and also we give the warranty. These are all things, and the supply chain and the installation, everything end to end. That is the delivered. This is what we call the Smart Building Complete. If you want to know more about, just visit Simon website. We have something called Smart Building Complete. We have some infographics and many details. And coming to the how do we build, couple of things in Simon, what we have. For enterprise land, we have end-to-end connectivity on the copper, fiber, and racks and everything. And for the smart building, yeah, we have the intelligent patching solution where you can monitor the physical layer, zone cabling, category 6A, category 7 cables. And some of the interesting fact on these outlets, if you see those outlets here, the same outlet, we can mount it in a faceplate either angled way or the flat way. You can mount this one the flat or angled. Most of the things, it's only Simon has that one. Any other manufacturer, you want to mount it in the angled way, you have to change the faceplate. And if you want to change it in the flat way, you have to change the faceplate. For us, you just remove it and put it in the angled way, it works. And then the connectivity, especially on the connectivity, the patch cords what we have is not a crimp type, it's a PCB type to reduce the interference, crosstalk in it. The RJ45, what you are seeing, Simon, it has a PCB inside, not a crimp type. Reduce the twist on it. Ultra high density patch panels, 48 port in 1U. And the MPTL solution, Z-plug. What is MPTL? I have a MPTL, what is it stands for? I just said. I have a gift for them. Yes. Perfect. Thank you very much for writing down that one. Modular plug terminated link, MPTL. Thank you. You have that one. We still have it. You still have time to win some other this thing. So that is MPTL we have. And then category 8 connectivity. This connection or the connector, what you are seeing, the interesting fact on this one is it is developed in 1999 for category 7, 600 megahertz. When we developed this one, that time it was 600 megahertz, category 7 was there. Later on, category 7A standardized for 1000 megahertz and 1200 megahertz. We said the same connector will support category 7. 2 years back, category 8 standardized for 2 gigahertz, that is 2000 megahertz, standard released. We said the same connector will support 2 gigahertz, take it. We didn't change the part number, it's the same part number for category 8, also same connector, no change in it. And if you ask me what is the maximum bandwidth it can support, I don't have any clue. Our R&D team knows. They are waiting for category 9, 10, 11 to release. Then they will say, we have to change the connector. Till that one, I don't have any clue. This will keep on going on. And other things is intelligent patching solution, which comes with two varieties, like the software and the hardware. Both together works close together. If someone removes a patch code, it will immediately alert the system admin. If unauthorized access to the network, someone plugs in, it will alert to the admin that this place on this floor, go there, there is somebody, unauthorized person is there accessing your network. It will redirect those things. So it's an intelligent patching solution. And also we have something like the ruggedized solution for industrial solutions, outdoor or in the factories or in the car park and all those places. That is the ruggedized solution with the patch cords and the boxes and all, IP rated, not IP44, it's IP66 and 67 rated. You know, how many of you know IP rating? The ingress protection rating, IP, there are dust and then the water, the 2-digit represents. And before I close the smart building and take the break, I just want you to visit our website. We have application guides, very, very informative for smart buildings, like PoE lighting, what we discussed today. The audio visual, I didn't touch much of audio visual, but yes, the SDVOE is there, and the security applications and Wi-Fi. There's application guides there. Download it, free to download. Just have a look at it, Converge IT and all. It's a very good, what is it? The information, we have it in our website. Sometimes I used to hear our competitor come to our website to learn about the industry standards and shielded cabling solutions and all. They don't have those details. We are already publishing all those details in our white papers and blogs and all. So that's all for the first session of mine. And if you have any questions, feel free to ask. Yes?
Hello. So I will ask two questions, and especially on the single pair Ethernet that you mentioned.
Yeah.
For me, it's kind of, it's taking us back to, what do you call it, RJ11, because when we used to have RJ11 for telephones, you just had two cables that you were using. But what would that mean for connecting to devices? Are you still going to use an RJ45, or there's a special connector that you use? And what will happen to the devices that, are they going to have ports that will take the single pair Ethernet? That's the first question. And then the second one is on the PoE, the 100 watts that you mentioned, that you can't bundle too many cables, or there's a way that you have to bundle the cables if you're going to do, PoE for devices in smart buildings. Now, when the cables are going into the rack, because you definitely have to have them bundled together to get into the rack, what do you do bringing the cables down into the rack?
Okay, great. You will deserve a gift, by the way, because you asked the good questions. That's two questions. You'll give only one. Single pair Ethernet, they standardize the connector. It's not the RJ11. It is like a LC connector, same like LC connector, but it will have a two wires on the down, and the form factor looks like a LC connector you plug in over there. And the device will have the LC connector. There are three connectors. They standardize, one for indoor, one for outdoor, ruggedized connectors. And there's in the car and all, you can't use that connector because it's so bulky. And your sensor is very small. Your connector is bigger than the sensor, so it's difficult for that connection. So still there is a gray areas are there, especially when it comes to, when I said here, the upcoming one, where is it? Oh, sorry, not this one. If you see here, the upcoming single pair multi-drop. Multi-drop means you can loop the cables. The sensor to sensor, you loop it. Loop to one sensor to the another sensor to another sensor. So there is a gray area of how you will connect 4 wires looping, daisy chaining two wires into one connector and putting it there. There is a screws and put the wire and tight it like the old RJ11. If you terminate it on the back side, you put the wire and tight it with the screws. Those things also there on some of those devices. In the cars, it might be soldered on it because car mainly they are trying to reduce the weight of the car. So that's why if you see the car uses 28 AWG cables, smaller cables in the cars for 15 meter. 25 AWG one. So connectors is not completely, there are 2 types of connector already standardized, but still there will be more will becomes in IEC. And it is not backward compatible to your Ethernet switch 4 pair. If you see here, no inherent compatibility with 10 base T or 100 base T. If you have a normal 4 pair Ethernet, it will not work. You need a single pair Ethernet switch and then connect it there. So it's entirely, it's a Ethernet, but the protocol they use is 802.3 BU protocol. And coming to the bundling size, that's why the Simon, the standard recommends refer to the manufacturer guideline, how much you can bundle it. The issue is, if you see the PoE type 4, which is 90 watts or 100 watts HD base T, and you are using category 6A shielded cable, you can bundle up to 24 cables. If you are using a UTP cable, you can't bundle it. That is one of the reasons why we always recommend go with shielded cable with 75-degree temperature rating on it. In the cabinet, I know the issue when you do the bundling. The one highlighted there with the red color, Simon does not recommend more than 96 cable bundling due to the manageability. It's difficult to manage it. My personal, don't quote it from the Simon official one, my personal recommendation, don't bundle more than 12 or 24. Easy to manage it. If you bundle it like 96 cables or 100 cables, it's difficult to manage. It looks so difficult. Copper cable will not listen to you. You have to, fiber cable easy to manage. These fiber cables easy to manage, but copper cable is very difficult. I've been in this, I started my career carrying the ladder, pulling the cables long back. When I didn't had any job that time, somebody said, okay, are you willing to do a technician job? I said, yeah, let me do it. And then I started pulling the cable. That is when I started. It's very difficult. That time it was Cat 5e cables. It was easy to manage, but Cat 6a cable, not that easy to manage unless you know that how it works. I hope I answered that one. After a long time, last month, in January, when I visited Uganda, I had a chance to go and pull a cable in one of the site visit, and I felt so happy. I started, if you look at here, I started doing the cable management in the cabinet. I put off my, I was the one taking the photo. I did the cable management, routing the cables and terminating it over there. I felt so happy. I went back to my previous life. The guys were trying to do the cable management, and these cables, when you do it straight way, they didn't know how to do that one. They are taking everything one by one and then managing it. I gave them, there's one expensive tool which can save your life. If you see that the lady holding that one, that is the tool I told them. Use that tool and put the cable and pull it. It's very easy to do it. I just grabbed the cable over there and cut it and then tied it and show them. You don't need any of those things. And they were saying, with this one, they can terminate the whole 142 cabinet in a day, easily managing properly, instead of they are spending like a week to do the cable management. Simple idea I was telling them. So if you have any installation going on and you need a support, we do have that kind of things. What is it? The toolbox training. We come there, train the technicians, train the engineers, If need, I can remove the jacket and then climb up the ladder, pull the cable, show them how to do it. Yeah, I am happy to do that one, going back to my old age. Thank you very much. And if you have any questions, feel free to ask, or we'll meet in the coffee time and then we can have a discussion.
I
Happy
think
to.
there's another question.
Oh, yeah.
Yeah.
Thank you very much for the presentation. You did state that if you're doing a Wi-Fi design, we should run 2 cables instead of 1. Is it just for redundancy, or are there more interesting reasons why we should do that? Thank you.
Great one. Maybe you want to say something on that one, why we need a second one? The second one is, first of all, these Wi-Fi 7 need high power, and you need a PoE power over there. And secondly, the throughput, it is 20 gig throughput is giving to the devices on the other side, and your backhaul is 1 gig, there will be a bottleneck. So at least you need to have like 2 links of, if you see there, 2 links of 5 gig or 10 gig on the backhaul, which can give you 20 gig on the backhaul, which can give you throughput on the other side. Otherwise, you have a bottleneck over there. Anything else to add for that one?
Yeah, I'm going to add on the redundancy portion. Seeing that, and I'll discuss this in my presentation as well, Wi-Fi is de facto standard method of connecting. We always connected with, you had your RJ45, your desk, those days are gone. So now an AP is becoming a high availability device. It's not just more one AP, this thing connects everything in the office building. So the idea is to actually, where possible, I'm not saying all clients will do this, but to run 1 cable to 1 switch and 1 cable to another. So both power sharing and redundancy from a device and power perspective. So also on the throughput side, yes, but for me, more redundancy, keeping the network up and running is for me, the more important portion from dual connectivity.
Yeah, because people, they don't want to do electronic free days.
Yeah, exactly.
They want the Wi-Fi always.
Yeah, I said I will do the 12-hour challenge, but I'll do it at 8 p.m. and then tomorrow morning, 7 a.m. when I wake up, challenge done.
Yeah, good one.
So, any other questions, please?
Yeah. We have one.
Okay, there's one here.
Thank you very much. It was a very interesting presentation you gave, very insightful. Thank you very much. You did mention, though, that the speed at which the technology is advancing is quite significant. Things are becoming outmoded very, very quickly, and I think your colleague even confirmed that. How relevant do you think the Cat6a cables will remain in the near future? Will they become obsolete? Because a lot of infrastructure currently is relying on that Cat6a type of cabling. Thank you.
Good one. So we have 3 persons, so we'll get the 3 for this session. I had like 4, so all the 4 will be completed now. So just give the 3 more from there. Remaining we'll keep it for the next sessions. Good. The category 6A, yeah, it used to be, the first one was data center standard started recommending minimum Cat 6A. I'll come to your question, but before that I want to go a little bit back and then take that flow to your question. And then intelligent building started saying minimum category 6A. Healthcare standard says minimum category 6A, and the schools education system standard says minimum category 6A. But now each and every standard says minimum category 6A cable you have to put it any green field. That's because of this Wi-Fi. One of the cases for Wi-Fi and future proofing it. Now going to the category 6A to category 7A. The advantage with that one, I already mentioned the reach. It can reach more than 100 meter without derating, the temperature rising and all on the category 7A. And there's a category 8 is in the industry. Category 8 is there, but category 8 is designed for data centers, not for the building. The maximum reach for category 8 is 30 meter. It can't go beyond 30 meter. When it goes beyond 30 meter, the speed will reduce to 10 gig. So it's an overkill to use a category 8 in a LAN cabling. If you ask me where this one will stand, 10 gig on Cat 6A still is there. On the copper, 25 gig and 40 gig is standardized. Cables are ready, connectors are ready, but the active device is not yet ready. I don't think even Arista is looking at that direction to have a copper with 40 gig, no. Because it's just a waste of money. Because everyone talking about 800 gig, why you want to use a 40 gig in a data center? So I don't think there will be something will come with a 40 gig on a category 8 with 100 meter. When it comes, then all the laptops, switches, everything can go for 40 gig. I don't see anything is developing in that direction in IEEE. They stopped at 40 gig on category 8 in data center on copper, but still Cat 6A is much relevant for the near future. Don't worry, if you are in Cat 6A, you are in the safe side.
Just to add to that as well, speaking about high speeds, anything above 100 gig is purely fiber. That's something to consider. So a modern fiber plant, right, also of course important. 100 gig, 200, 400, 800, 1.6, all of them purely run on fiber. Just fiber, if you talk about 500 megahertz on, a copper cable, fiber cable has terahertz of capacity. So it's a completely different game.
Yeah, fiber, especially on single mode, if you see single mode, there is no limit on the speed on single mode. The only limiting factor for single mode, the speed is your active device. How much speed you can do it will support, is unlimited, future proofing. That is where we maybe in the next session I'll talk about what is limiting factor, why we can't go beyond certain speed, what is the limiting factor and how we can overcome those things, how the transmission techniques, I have in deep of signaling. Maybe some of you might be interesting on that one, the signaling sine waves and zeros and ones. Because you're all engineers, you might be knowing those, some of those things might be interesting. You might be getting more interesting fact on the next data center session. Yeah.
My final comment, the limiting factor is money. It's the only problem.
The issue, the thickness of your pocket.
Yes, exactly.
Yeah. Great. Are you ready for the yeah, please.
Oh, I thought I was climbing up, you'll be giving up for Dinesh. That has been a very insightful one, right? And let's give it up for ourselves. I think we've been a very, very good audience and participants as well. At this point, we'll be going out for our coffee break. But before we do that, please, it is very important. Each and every one of us here will have to make sure that we've registered. So if you're here and you haven't registered, as we make our way down for the coffee break, take advantage of that and register. Yes, because we would have to take note of all the participants who are here. One of the opportunities that we have here at this conference is to network. So even as we step down for the coffee break, please speak to somebody, engage, network, because you don't know. Probably from here, the next gig, you'll be working with a person. Let's take advantage of that. At this point, we'll be stepping down to the car park. The canteen is on, where you step down on your left. Yes, on your left, we will be having, on the right rather, sorry. Yes, on the right, we'll be having a 15-minute coffee break. 15 minutes, please, 15 minutes. We're already behind time. We want to take advantage of the time that we have. So please, 15 minutes, we are back up here, and then we continue. At this point, we can make our way to the canteen for the coffee break. Thank you very much. So please, if you haven't registered, the admin desk, the secretariat desk will be waiting for you. Even as you make your way down, if you haven't registered, please make your way to the secretariat. They will take your details and register you accordingly. Once again, if you want to use the washroom, it is to the very left of the auditorium. The exit at the very left of the auditorium. You can make your way there. Thank you. See you in 15 minutes.
What did I say? You see it. Yeah, fine,
With cutting-edge solution speeds up to 400G, we are leading the way of this high-speed revolution. Our AI-ready PM4 optimized design
connected.
lower costs and lower power.
Hello. Right, so you're welcome back from the coffee break. So very soon we'll be having the next session, and of course, Dennis will be taking us through the next session as well. But before that, hello? Hello? Great. Before that, we would want to have a group photograph, and we want to do it now. Yes, because we understand that some people have very tight schedules and probably might take leave of us during the course of the next session. And we want everybody to be captured in this memory. So please, we'll crave your indulgence. We'll all move forward. We'll have our speakers stand here whilst others climb up here. So that if it is, I think it's too large a group, so we can probably have it in 2 sessions, or? Yes. Okay, so our director of photography is telling me I should do it in 3 sessions. 2. 1, 2. Right. At this moment, I will take instructions from our director of photography. Thank you very much, engineer. Right. So let's have the first group join our speakers. We'll take the photograph, and then the second group will do so. He says he can do it in 2. Yeah. So we'll have our speakers stand in front first. Yes. So some of us, let's come up here. Let's come up here. Let me step down this way. Sir, if you can join me. I think some of us can move this way. Yeah. There's a very tall gentleman at the back. Yes. I want you to be in the picture. Then let's just, okay, great. All right. Great. Please, our president is coming. Wait. Elect, yes. So should we have, please, the next group? Let's join. This is going to be a very large group because they are quite huge. You sure you can manage? Okay, all right. Sorry. Oh, that's fine. Mr. Director, I'm actually not sure you'll be able to capture everybody. I'm not too sure about this one. Yeah, he'll be shorter. He'll be shorter. No, if we can get a... Can we have the conference theme as the background, please? Media booth, can we have the conference theme as the background? Thank you very much. Sorry. Media. Right, so I believe we are all set and ready for the next session. We're going to have two presentations, after which we're going to take questions. So please, for the next presentation, if you have any question, I would encourage you to write it down. I believe we all have the notepads and then we have our pens. Probably you also want to put it on your notepad. It is right. So you note it down. We'll take the two presentations, after which we will take all the questions, and then we'll have the last session of engagement before we hand over to our chairman. So please, let's be attentive and listen to another wonderful technical presentation by Mr. Dinesh. Please, let's welcome him.
Okay. My 3-hour window is finished, so it's all, whatever you are getting now is just a, what is it called, is a discounted. If you get it, I will be happy. If you don't get it, still I am happy. No worries. The data center, again, I'll just explain a little bit about the standard, the data center standard. Data center is popping up like a mushrooms everywhere, all over the world. Wherever they find a space, you will find a data center over there and then building up. In the same way, AI factories is coming up. I don't think it is just in the Europe or in US, but in Africa also the AI factories is popping up. It's maybe too early for some of you might be hearing, but maybe next time when I come and stand here, I will show this slide I was presenting some time back. Now we already have the AI factory here in Ghana. And then finally, how do we connect? So the standard updates. First thing, I don't think anyone here did not use a ChatGPT, the generative AI, or at least once in your daytime, you might have passed through one of these AI machines through a AI factory. So, are you ready for this revolution in Ghana? Are we ready to put everything in it? The main drivers for AI is hyperscalers like Azure, Amazon, or Google Cloud, all those hyperscalers, they are the one main drivers. And then telco services, the MTN or Airtel, all those peoples, they are all bandwidth hungry people. They can't survive with 10 gig or 40 gig. They need a high bandwidth, the data centers. And large enterprises like banks, government organizations, and the big medical and all other big enterprise, they are also coming in it. And finally, this one was professional media center was one of the least considered so far, but now they are also like coming up. Like those TV stations, media stations, and all those people, they are also moving from those traditional coaxial, they are going towards the IP-based streaming and everything. So they are also need ever satisfying their need like a storage. You know, all the media house, they have to keep their streaming in their storage. So terabytes of storage, they have to keep it in their data center for years of streaming what they did. And it is expected, the global market, AI market is expected like 17% annual growth every annual till like 2030, like in the next 3-4 years is growing, the market is growing. And to support that market, you all know that the servers, you know, the compute servers, which is x86 based, like Pentium or AMD, all those servers are x86 based processor. That used to be the biggest market share that used to be in the previous era. But now it's changed. Everyone is going towards non-x86 machines. Like, have you heard about M1 chip? The Apple released the M1, M2, M3, M4 chip. Those are all non-x86 based machines. It is not x86. That is ARM based processor, like mobile phones is ARM based processor. It's not the regular compute servers. So that is where all the data center is going because it's high performing. And then is 40% increase we are going to see is AI machines, the GPUs, like NVIDIA GPUs. That is what is going to occupy your data centers in next couple of years. Is growing exponentially. And the similar way for because it's not x86, non-x86, it's x86 machine, it's scrolling. It's stuck. Okay. Now, let me make it here. Yeah, it's coming. It's coming.
Is the pointer okay?
Yeah, pointer is okay. It was scrolling. It is thinking what to show. And the speed, we were talking about 400 gig, but expect that 400 gig will goes down. The sale of 400 gig will go down. Not talking about the enterprise, but AI factory, they are not looking at 400 nowadays. What they are looking at 800 gig and 1.6 tera and more than 3.2. So have you heard about 1.6 tera? No. Now we are talking about that one. All this speed is standardized by Ethernet Consortium. So they released a Ethernet roadmap last year, December, for 2026 Ethernet roadmap. What is this year they are going to looking at Ethernet, how they are looking at. So they have divided the whole speed spectrum into different one, like 5 gig speed for automation, automotives, you know, the connected cars, connected device, self-driving cars and all. So they don't need heavy traffic. So that is 5 gig speed limit for them is okay. And the next coming is enterprise LAN and smart building and all. And then 5G connectivity, Wi-Fi and all. That is okay, like 10 gig to 25 gig. and then going towards the data center, service providers and all, which is 200 gig, and 400, 800, and 1.6 tera is on the AI and the cloud. So that is where we are heading in this year. 1.6 tera already cooking. And potentially 3.2 tera and 6.4 tera connectivity. That is where we are heading towards. This is the Ethernet roadmap. If you see the IEEE already talking about 3.2 tera, 1.6 is already in there, and 3.2 already a committee formed to do the feasibility study whether we can do a 3.2 tera transmission. Can we get it? Yes, it might come very soon in mid of this year. So these are some speeds on the 800 gig already there in the market. Those are all, if you see the connections on the last column, is MPO connections. MPO or MTP connectors. Have you heard about MPO, MTP connectors before now? How many of you heard about it? No. Have you heard about LC connector? Most commonly known as Lagos Charlie. And it's Lucent connector. This is the LC connector, which is one transmit and one receive, right? The MPO connectors are, I'll show the next one. MPO connectors are not one. I'll show you the next one. So coming up next is on its way, 1.6 tera on IEEE and MSA. The difference between IEEE and MSA is IEEE is a global standard. Anyone can borrow that one and manufacture the equipment. IEEE 1.6 tera transmission. MSA is multi-source agreement, is a combination of like couple of manufacturers comes together, come up with their own standard. That is the MSA standard. So it works only within that manufacturers, but it doesn't work outside their association. The LC connectors, you know that one, Lucent connector. That is the LC connector, one transmit and one receive. The data will be transmitting, light will be transmitting on the fiber one, other one will be receiving the light. That is the duplex connections, and the optics are, those are the optics, which is you connect to the server or switches. For the higher speed, one transmit, one receive is not enough. We need more fiber. So the QSFP is what you are seeing on the other side. It doesn't use empty LC connectors, it uses MPO connectors, multi-fiber push-on connectors. So these are not LC, it is MPO connectors. It has a 12 fiber in it, 12 fiber on the end, 4 will be transmitting and 4 will be receiving. So how does it works? The high speed data transmission. 10 gig, 20 gig, 50 gig will transmit on light. Just send the lights and receive the lights on the other side with PAM4 or there's one more is there. The other way is you run like 400 gig in 4 lanes and 400 gig on receiving on 4 lanes, which will give you 100 gig transmission. So this is how the higher the speed we can get it. So 1.6 tera we will be transmitting and receiving with not just 8, will maybe like a 16 fiber. So 8 fiber will be transmitting 200 gig, 8 fiber will be transmitting 200 gig, 1.6 tera you can get the connectivity. There are multiple options are there. So this is how the Ethernet works, the connectivity works, and you heard about the InfiniBand, right? InfiniBand is a new in the industry, especially on the enterprise side. It used to be there long back, but for the enterprise it was not affordable. InfiniBand was used by supercomputers. All those supercomputers scientist users or NASA users, they were using InfiniBand. It was so expensive to implement in an enterprise or in a colo or in a data center. Now, because of the AI, InfiniBand is becoming more affordable for everyone. So it's coming down to the common man. They can afford it. They can just get those InfiniBand. So the difference between why we are going with InfiniBand than Ethernet is that's because of the way Ethernet works and InfiniBand works in a different way. How many of you heard about OSI layers, Open System Interconnect layers? There are 7 layers. Yes. What are those 7 layers? The first one, bottom one is physical layer. Have you heard about what is the next one? Anyone? Correct? Network. Session, presentation and application layers. So what happens when a data I am transmitting from a device to another device, it uses from the application layer to the presentation layer, session layers and all, and then goes to the cable and goes to the next device, and then it will unpack. So every time what happens is, every layer, the data packet, it will add a data on the head and tail. So the data packet will be bigger, bigger, bigger when it comes to the physical layer. And it goes to the next device and unpack and get the final data out on the presentation layer, application layer. So there will be a delay. Data is huge. What if we do directly between the application layer to application layer instead of coming all the way down with individual layer? That is what is called RDMA, Remote Direct Memory Access. So from the memory on the other end to the memory on this end, put a bridge. It doesn't use the CPU to pack and unpack. It creates a bridge between the memory of this one to the other side of the memory, operating system's memory, and uses the physical layer to transmit the data. So it manages that way. So the advantage with this InfiniBand is the latency is far, far less. If you see, the latency is 1 microsecond. Compared to Ethernet, it goes up to like 100 microseconds, the latency. AI need a faster connectivity between the GPUs to render it. Assume you type a question on a chat GPT and you have to wait for like 1 minute. You will be frustrated to see that one. If you see a YouTube video and it is rendering, then what you will do, you just go to the next one. You don't want to wait for it. So that is what the human is going towards nowadays. The new generation is going that one. They can't wait for like 1 or 3 seconds more to see it loading. The same thing, why this InfiniBand is getting more and more. And the transmission technology uses for the higher speed, if you see that NRZ and PAM4, non-return to 0, the second one on the line, and pulse amplitude modulation. These are the 2 types of signal transmission. I'm getting into more technical, more technical. I just want you to know how the data is transmitting on these cables or in these fiber cables, how the data transmits and how it encodes. I hope it will be useful for you. The data, we all know the digital data transmits in zeros and ones, right? 0, 1, 0, 1, maybe 0 volts, 5 volts, 0 volts, 5 volts. That is how the data transmits. But in real sense, it uses analog lines. In the frequency, it uses the frequency. And there will be a delay from the 0 volts to the 5 volts. You know, it doesn't go immediately. It goes little slowly and then stay there, and then 5 volts to 0 volts, there will be a time delay. So the optics, what we use, or the devices on the other end, what we use, the data, the usable area to identify which one is 1 and which one is 0 is very small space, right? Let me use a pen. If you see here, from here to here, this space, we can't use that space because it is coming down. And also whatever is on this space, maybe I'll go to the next one. So whatever on this space, it goes above this threshold, it will always consider 1. And whatever which goes down here, it always consider as a 0. So this is very, very basic transmission signal, right? Ones and zeros. And if I take a snapshot of one specific pulse over the period of time, it looks something like this, right? Something is going from 0 to 1 here, or 1 to 0 here, or 1 to 1 and 0 to 0. So the overall available space to the devices to identify which one is 0, which one is 1 is only that yellow color box where you are seeing. The thing on this side and this side, which is this side and this side, you can't take that one as a data because it's transitioning happening from 0 to 1 or 1 to 0, transition happening. So the window what we have is very small window. We are looking at this one with this big, but in real sense it will be very small. You know, like 100 gig speed, it is going that much data, zeros and ones of millions of zeros and ones happens in a second. It will be very small window what we have. So this is non-return to zero, just zeros and ones. And there is another technology came in, which is PAM4. That is pulse amplitude modulation. In this one, we have 4 layers, 0, 0, 0, 1, 1, 0, 1, 1. We can transmit double the speed, right? So that means from the previous one, what I showed, NRZ, we can go with PAM4, we can get double the speed. But the issue is the window will be wider. It is wider window. If we get the next level, we can get it half of it. So that is where we have the PAM4 with 50 gig and the 100 gig, which is 53.1 Gbaud what we have. So it is 50 gig 2 sets, which the remaining 3.1 will be used on this space for on the other side, both sides, which can carry 100 gig speed. This is what we have right now. We can't have PAM8 or PAM16 because the space, the yellow space, what I mentioned, it is so small, it's very difficult to achieve. There will be a lot of errors we can't have. So the only maybe like 8 of it to 800 gig, or maybe like 16 of it for 1.6 tera. That is how we go. This is the limiting factor for going the higher the bandwidth. We can have multiple lanes and aggregate everything, get a higher speed, not with the higher capacity. Like, for example, we have 4 lanes of road and your car is taking only like 4 passengers, so you can get 14 passengers at a time, or maybe 16 passengers at a time. You can't have a bigger, your car space is only 4, you can't have more people in it. So what you can do is add additional lane, widen the road so you can have more vehicle. That is the concept of what we have in transmission, signal transmission, right? So this is more of going into more in deep in technical. Now I'm just getting into the factory where we can do a lot of things inside the factory. So what is the difference between AI network and the regular enterprise network? If you have a regular enterprise in your in-house and then you have a AI network, you want to build up AI network, first thing is need a high bandwidth. Otherwise you just type it and then go home, have a coffee, come back, or take a nap, come back, then it will show some output from that one. If you have a 10 gig or 100 gig, you need like 800 gig on the server. Power consumption. I'll show you the power consumption, how much power it needed. Prem mentioned is gigawatt. Yes, really it's need a gigawatt. In a data center, when I started the data center designing and all, average medium density was 4 kilowatt per cabinet, and become like a high density, become like a 15 kilowatt per cabinet or 20 kilowatt per cabinet. Now we are talking something like 300 kilowatt, 150 to 300 kilowatt per cabinet. On a 600 by 600 footprint, you need like 300 kilowatt. From where? We were talking to one of the AI factory, and the NVIDIA president was there, and then he was telling, I need only this much space. Why you have this big data center? Just give me like 10 cabinet space, that's it. And give me like 3 megawatt of power and cooling for this space. 3 megawatt power. You don't need all these spaces. This is DGX B200. This is one of the GPU, fast selling GPU. Blackwell. Now there is a new one came recently. Rubin. Yeah, Rubin is newly released. You know, every 2-3 months they will come with a new GPUs. They don't wait for the ROI for their existing what they have it. This one is 14 kilowatt per unit. It can do like 144 petaflops. Flops means floating operations per second. 144 petafloating operations per second. This small machine does. It's power hungry. It has like 8 numbers of 400 gig ports. You can see on the center here, where you see the 8 numbers of 400 gig OSFP ports. You cannot mount throughout the cabinet everything. Maximum you can mount like 4 of it. 20 nodes in one, these things. And that one required hell lot of cables. Lot means more than 8,000 cables in that cabinet. That is where we come in. We give those InfiniBand connectivity. If you haven't seen the 800 gig connectivity, this is how it looks like. The 400 gig and 800 gig connectivity in the GPUs. This is how it looks like. And in the AI network, it uses GPU, as I said, but it will have CPUs also. The compute also it will have. Those compute will be on the front end, and which is generally Ethernet, but on the back end, the GPU will generally on the InfiniBand or Ethernet, depending on the pocket size. It has a 4-quadrant, like the front end switching, and then front end compute and storage, and the back end, which is the GPU with switching, and then GPU with the back end GPU processing. These are the 4 quadrant. It will have all the AI machines. This one is 800 gig. What we've written over there is just like 3 months old slides. Now we have 1.6 over there. Those 800 has changed to 1.6 now. That is a quick overview. We designed those things. Many of the AI factories we designed globally with the TSG group in Simon. And some of those images, what we shown is the real design, what we did it for the AI factory. It's very complicated. It's not so easy, like connect a wire and bring up the server. No, it's not like that. Now let's look at the design consideration, how we need to consider so that your data center will be ready for AI factory or maybe the existing one. First thing is, what is the standard for data center in TIA? TIA standard for data center. I said the last year, mid of last year is released C. Before it we used to have B. What was the standard, the TIA standard? My second gift, I'll take home the second one also. It's 942, C is the latest one, and ISO 11801-5 is data center, or 6, one of that one. Minimum you must have one MDA, main distribution area, to connect all the servers. That is what is recommended according to the standard, and connects to all the equipment distribution area servers, server cabinet. Instead of connecting that one, standard recommends have a zone distribution area. Don't think it's very complicated. It's just a rack hanging from the cable tray. You just put a 2U rack hanging from the cable tray and connect all your servers down from using a patch cord. This is what is the zone approach in the data center is what recommended in data centers. The good thing is that in future you are adding a new server or removing a server and replacing with a new model. What you need is just some patch cords to connect it. You no need to touch the permanent link from it. The cable coming from the main distribution area you are not touching. Just the patch cord, you keep on changing it. So this is what is recommended by the standard. And secondly, as I said, you need to have a MDA main distribution area. Most of my design, I do somewhere around 50 to 60 data center design in a year for Africa region, 52 countries. I do it somewhere around that much, and it's complementary. I will show a couple of slides where how the design will looks like, how we do it. Almost all the design I recommend to go with the central patching location or central patching zone. What does that mean is, if you have a servers and the switches and the storage in the data center connects to that central patching location, a hub, central hub. When you are adding a new server, you just bring it to the central patching location, some cables. You have connections to any devices in the data center. That is the hub, center hub. So if we assume we have like 100 servers here and a new switch came in, I just bring a cable to the central patching location which can connect any of the server in the data center. And the same way, if I have a storage or if I have a switches or the servers, which brings in, just need to bring a cable to the central patching location. This is what is 11801-5 recommends in the data center. Use a central patching location and do the connectivity. That central patching location is not a crazy thing, it's just a cabinet with, not the cabinet, maybe best one is the open rack, and then connect all the patch panels and just make a patching. It's just like a hub, a matrix hub. This is what is best practice in data center. And the connectivity, as I said, if you are not going for 400 gig, 800 gig from the day one, go with this plug and play with patch cords. You see that blue color patch cord? You connect to your SFPs. In future, you are upgrading to higher the speed, like 400 gig, 800 gig. Your cable will remain same, only the patch cord you change it and the adapters. There you are done. You no need to re-cable the entire data center. You will get the connections. And also, if you have new switches, which is 400 gig, but your servers are 100 gig, you can replace that one with a splitting. So 400 gig, you can split into 400 gigs and you can connect it. Or else you can go with the one I showed you, the direct attached cables, which will reduce the cost. Like 80% of your cost will reduce. It's much, much cheaper. These are the connectivity, but now I'm just going in deep how signal transmission or what is the consideration when you do the fiber cabling. You know, in the fiber cabling, it doesn't transmit electricity, it transmits light, right? So the light will transmit from one end, the light will on off, because light will go, laser lights will go very quickly on off like this. So the data will transmit on off on the other side. When I send the data from one side to another side, the first challenge, like copper, we have so many challenges, interference, heating, and the arcing and all. In fiber, we don't have all those challenges. But the problem in fiber is the intensity of light will reduce when it is going further away. If the same thing, if I do it like this, it is so bright, when I go far away, the brightness will reduce. That is called the dB loss. So we will have a loss in the cable. That is one issue. And the second issue, when we send a signal, especially on the multi-mode, we don't use the laser light, we use LED light or VXL. So the LED light is a flooded light, it is not a pointed light. So when there is a flooded light transmits, some of the rays will take a longer path. Some of the rays goes shorter path. So the shorter path will reach earlier than the longer path. So the longer path will reach little bit slowly here. I think I should change it to the laser pointer. Yeah. You can see it will be like if I send in 1 nanosecond light on, the other side I will see 1.2 nanosecond on. A continuous on, because some of the light will take longer path to reach there. When I send the second signal, the first one will comes early and the second one will comes little bit later. So the gap between the on and off is very less. So the only way we can do that one is either send the signal little bit slowly or reduce the length of the cable. So in short, the fiber cable can support 1 gig, 10 gig, 100 gig, 200 gig, X terabytes it can transmit. The only limiting factor is the distance and the loss. If it is far away, it cannot send it. If it is shorter, it can send higher the speed. This is the reason why we have. And to avoid that one, we have something called, this is just a cross-section view of those things, which comes first and which comes early, which comes last. If we have something like a graded index, the fiber core, the glass, we do outer layer glass in such a way that whichever the light comes in the outer layer will go faster, whichever the light is in the center layer, it will go slowly. So at that time, all of the things will come at the same time. That is called OM3, OM4. If you heard about OM3 cable, OM4 cable, this is what is the difference between the OM3 and OM4. OM3 can give you like 10 gig at 300 meter, whereas OM4 can give you 550 meter extended reach, little bit more distance you can get it. When it comes to the loss, when you have multiple connections, like multiple connections, patch panels and all, you will have a more loss. And if you use a regular, this is 400 gig, the limit is 4 dB loss you can have in a cable. By the way, 3 dB means is 50% loss. 4 dB means it's like a little bit more than 50% loss, it's acceptable on the other end. If you use multiple connections in between, you will end up with somewhere around 5.6 dB loss. It will not work. That is where the CMON comes in. Our cables are ultra low loss, which can give you 2.8 dB. There is no standard defines what is the ultra low loss means. This is the value. Every manufacturer, they pretend to be, mine is ultra low loss, mine is ultra low loss. All those marketing words, don't listen to that one. Take the data sheet. Look at those values. 0.2 dB, 0.3 dB is written over there. You have to look into those values and then take a decision which one you want to go, whether it will work or not. In the same way, for 400 GB DR4 is 1.4 dB loss what we can get it. And CMON is the only manufacturer who has third-party certified ultra low loss cable at this one. Most of the manufacturers, they claim that it is ultra low loss with our standard loss. What we say it is our standard loss, for them it is ultra low loss. So don't believe those marketing words. Look at the data sheets. And how do we do it? How we connect it? How we can do the data center to AI ready or future proofing it? We have many solutions from CMON. First one is data center design services. If you see, the data center design services is complementary. The front bencher would like to say it is free. But engineers, as we all know, how much effort will go behind this one to come up with something like this. I would say more of is complementary, not is free. You don't feel it if it is a free, you don't feel the value for it, right? We come up with a complete design, a drawing, low level drawing, single line diagrams. These are all the live examples what my everyday life goes through. And the rack layouts and complete single line diagrams for you, complete detailed drawing, rack elevations, loss limitations, what are the loss, fiber loss, budget loss, and what are the application it can support from the day one to the future. If needed, we can come up with a 3D drawing. If you have a BIM modeling and all, we can superimpose our solutions into it. All these things, when we do it, it is much more than the free what you are listening from these people. It is just a complementary what we can do it for you. Is a data center design services. According to the standard, we'll design the data center and give it to you. You just need to get that one, and the installers just go there and install it. For the end user, just release it for the tender. Take it and put it in the tender. You'll get the right solution in the tender. And if it is a consultant, we can assist you with that one. And for the connectivity, from 10 gig or even if it is 800 gig or 1.6 tera, 3.2 tera, talk to us. We'll get it done for you. And for the copper, category 6A, I am not talking about category 5E or category 3 or any of those things. Data center minimum Cat 6A, category 7, 7A, category 8 is available with our portfolio ready to dispatch in our shelf. We have something called ultra high density fiber enclosures, which can give you like 96 fiber in 1U, or ultra high density with 144 fiber in 1U, or 860. So the real estate in the data center for the cabling will be much lesser needed. You can use the remaining space for your compute or storage. So for cabling, you no need to spend a lot of space in the data center with this ultra high density. And the one I mentioned, the zone distribution, we have like 2U, 4U and all, which you just hang it from the cable tray and then connect it. And did I finish? Yeah. And finally, end-to-end solution for the data center, you name it, from the copper or fiber or connectivity, one-stop shop to go with. From the design to the implementation to the handover, end-to-end, everything we will join hand to hand with you and then make sure it is delivered over there. Nothing much I can say for now from it, and then not to say much about why Simon. You already know why Simon, 123 years young boy in the room, and giving all the expertise we seen throughout the years, and commitment to the industry, and then our supply chain logistics and the partners, installation supports and everything. That's all for me for today, and I will leave the floor for my colleague, for Arista, to take over from here. Thank you.
So, great. Well, let's give it up for Dinesh again. Some will be doing the next presentation, but we know that after listening to this insightful presentation, definitely you would have some questions. So I would want to know if there are some few questions on the second presentation that Dinesh just made. Would want to take those questions as Tom prepares to also give us his presentation. Are there any questions for Dinesh? Okay, there is a hand up, a couple. So even as you take your seat, please, you get ready to answer those questions for us.
Thank you. I wish I had a present to give to you, Dinesh, but I didn't bring any present, so you see me later. Thank you for the presentation. I have two questions. The first one is a sales question. What's the percentage difference in cost between the low loss and the ultra low loss cables from Simon? That's question one. Question two, you mentioned 14.3 kilowatts per cabinet, correct? As a power consumption, power requirement. The 14.3 kilowatts, what are the components? Does it include lighting, ventilation, air conditioning, etc., etc.? I would like to know, please. Thank you.
The cost difference, it is not my headache. I don't take the Panadol for these people's headache. I will leave it to them how much the cost difference between ultra low loss and the low loss. But one thing I can assure you, it is much better when it compares to the tier 1 brands in the market, and in the quality wise, support wise, and the price wise. I don't think we are behind of any of there. We are ahead of everyone. And the 14.5 kilowatt which I mentioned, it is 6U machine, a GPU. So if you put like 4 of it in a cabinet, that will be like 14, 14, 14, 14. Somewhere around 60 kilowatts, somewhere nearly 60 kilowatts will comes in a cabinet. And that 60 kilowatt, you have to give the power and the cooling 60 kilowatt to that cabinet. The raised floor what we have, or maybe in a containment with a aisle containment, 60 kilowatts to push in a 60 by 60 tile, it is highly impossible. The only way to go with for cooling, it is direct to chip cooling, DCU. You put a cooling unit in the cabinet and run a pipe, the coolant pipe, which goes directly into the CPU, and cools and then took it back, and then you have the secondary cooling goes to the chiller. So you have a, like this AC, for example, you keep this AC inside the cabinet, and the vent over there, instead of the vent with the pipe, you take the pipe directly to the chip and then cool it. So it's the direct chip to cooling, or the alternate option is immersion cooling. Put it in a coolant tank and then cool it. So it is not so easy what we think. Just put a in-row cooling or a down-blow cooling or anything like that. We can't have that one for these kind of machines. Yeah, that's why I said that they need just 10 cabinet space and then 3 megawatt of cooling for 10 cabinet. It's not easy to push 3 that much. You know that better than me, how much difficult to push that much cooling to the small space. Use a direct chip to cooling. You will have the ambient cooling, but direct chip to cooling is what will go.
Right, okay, so
Do you need the clicker?
Michael Thom is ready with his presentation.
You want a clicker?
And as we heard from the beginning, this conference has been made possible by the partnership between VHF Solutions and CMON, and also the Kanketsi of Ghana Institution of Engineering. So the next presentation Dinesh, it looks like there's another question for you.
Click on continue.
I just want to pick your thoughts on, recently we had in the news, Elon Musk thinking of setting up data centers in space. What's your comment on this? Is that the future of data centers?
Wow. You see, some of them, like, have you heard Microsoft, they put the data center in the ocean. Have you heard about that one? They put it in the ocean so that the ocean will keep on cooling it. So it was experimental, and then they pulled it out from the ocean. Because if you want to change a switch or a server, or you upgrade it, you should know the scuba diving before you go in. One day it might be possible. Only thing I can imagine now is to take a glass of water to the space. You know how much $1 million they will spend. And these servers and the storage and all, every 6 months you will keep on changing. The new things will come. 1 year later, the items in the space will be outdated. You have to bring it back, or you send another one. Yeah. For him, everything is possible. He can put it there. Maybe for experimental, they can start it. But if one day, maybe my grandchildren, when they grow up, they may say, "Oh, I have a cloud server in Mars." Maybe, who knows? But it may be very shorter than we expect, because things are going so fast in IT. Yeah, it's.
Okay, please, is there any hand or any question for Dinesh before he takes his seat? He's been standing for quite long.
Let him stand.
All right, okay. I know, is there a question here? All right, okay.
Thanks for your presentation again. But just wanted to find out, how do you track performance of the cabling in the data center over time? Because I believe over time, the speeds will degrade and all that. So do you have any equipment? Do you have any standard procedures that you recommend to track performance in the data centers?
Good question. The tracking of the performance degradation happens to the cable over the period of time. That's where we give 25 years warranty. 25 years warranty, the performance will not degrade. The day one, what we are committing, this is the speed it can work with IEEE or ISO or a TIS standard. These are the things what we have it. After 24 years later, you test it, it will have the same performance. It will not degrade. If you get, I don't know about the other manufacturers and all might have degrading, but CMON, I can guarantee you, is the CMON is what gives the warranty, and it's directly from CMON to the end user. even tomorrow, if I am not there or he is not there, 25 years, we don't know what will happen 24 years later, but Simon is committed to give that warranty for that one. To track that one, how it is degraded or not, there are tools available to test it, where you can test. Lot of graphs are there. Maybe it doesn't make sense for you, but if I see the graphs, I know what is the problem over there, what happened to the cable, because I see the graphs every here and then I analyze those graphs, and then I can tell there's a problem with the cable or connectors, or it's okay. And for the data transmission, maybe in the active side, you might have something to track the connectivity between the two switches or anything, if the data packet loss and everything happens. Yeah.
Yeah, it's more that's more on an active level, where we can see if it's started running errors on the links. You can see typically pointing to faulty SFP or the fiber is damaged. But typically, if you leave a fiber in the ground, don't touch it, don't drive over it, don't pull it, don't bend it 90, it will work forever. Oh, not forever. Nothing lasts forever, eh?
All right, at this point, let's give it up again for Dennis. I think now he can take a seat. Yes, finally, he can take a seat. But before you do your presentation, Michael Thom, a little introduction. So Michael Thom is a systems engineer at Arista Networks, focusing on customers across sub-Saharan Africa, including South Africa, Ethiopia, Uganda, Ghana, and Nigeria. He brings on board experience across enterprise and service provider environments, having worked with technologies such as load balancers, deep packet inspection, firewalls, DWDM transmission systems, and core switching and routing platforms. Michael holds multiple industry certifications, including being one of the first F5401 certified engineers and the first F5402 engineer in Africa. Let's give it up for him for that. With a strong focus on design engineering and operational excellence, he helps customers build scalable, resilient networks using Arista EOS, emphasizing on repeatability, automation, and visibility, so engineers can spend more time engineering and less time troubleshooting. That is just a little about Michael. Yes, we are eager to know what you have for us. Okay. I know he'll be speaking to us on updating technologies, right?
Yeah.
Great.
Perfect. Thank you. So it's actually very nice to be here. I am actually also an engineer. I studied computer engineering in South Africa, so I didn't go further than that. I went into networking. Good choice, bad choice. Let's see in 5 or 10 years. I don't know. So far, I'm enjoying it. So this is engineering, right? Networking, you think, switches stuff. It is actually engineering, right? It's not just, oh, we put it down, it works. It's engineering, thinking, problem solving, all of it. So number one, thank you. Hello everyone, ladies and gentlemen, cyborgs, AIs, whatever we have here today. If you think I'm kidding, right? If we go, hold on, oh, technology is winning me already. If we skip the agenda and we look at what we have here, has anyone heard of Reddit? So about a week ago, someone launched a Reddit for AI networks, AI agents. So this is fundamentally AI agents talking to one another. In about 4 days, they created their own cryptocurrency, created their own language, so you can't understand them, and they may be plotting to destroy the world. We'll see, maybe in a week or two. So we are living in super, super interesting times. AI networking, as we can see, right, 400 gigs, 800 gigs are accelerating like crazy. And I honestly think this is just a start. So, yeah, hold on. Okay, so just an intro to is Arista, right, and where we come from. And I'm going to go back to the 3 faces you see on the top right-hand side there. So the biggest one right there is Andy Bechtolsheim. A pioneer in Silicon Valley space, right? He was the main guy behind Sun Microsystems. He sold it. He was one of the first investors in Google as well. So massive, background from Andy in a technological space. He's been in the space forever. He still leads us today in these high-speed Ethernet networks that we built out. But what changed and what started Arista was actually Andy being approached by Google, Larry Page, rather than saying, listen, Andy, we are looking for devices that can go 10 gigs on the access layer and 40 gigs up. This was in 2003, 2002-ish, right? And Andy said, okay, yeah, let's go look. Let's go to Cisco, let's go to Juniper, let's go to Aruba and all the other companies that doesn't exist anymore, right? And went there, guys, we're looking at 10 gigs on the access layer. Cisco told them, you guys are smoking the best stuff ever. Not possible. It's just not possible. No one can do it today. We won't be able to do it just now. Okay? Juniper, all those guys told them, crazy ideas. Hold on, go back to the drawing board, get more efficient protocols, stop. Okay, and he said, yeah, I don't accept that answer. I'm going to go and look what we can do. So he got to Ken Duda, which was one of the lead developers of the Catalyst 4500 at Cisco, right? Told them, we have this idea. We want to go faster. We need to go faster. The guys are asking to go faster. Okay, let's go have a look. Let's see what's available in the market. So they went to all the CPU vendors, kind of, right? Broadcom, Intel, these guys, asked them, do you guys have any networking chips you are building? Now, the reason why I did that was because the CPUs we get, right, it follows Moore's law, which means that every 2 years, the amount of transistors on a CPU doubles. This Moore's law is still being followed today in the GPU space and all of its space. So he went to them, guys, you don't have something that we can kind of use as a networking chip, right, which is fast? And Intel said, yeah, we actually do have something, some internal project, right? It's a forwarding chip. It's very stupid, right? It's super fast, but can't do anything else. It's just can forward, it can switch packets, that's what it can do. And that fundamentally is how they said, listen, okay, we are going to build software around this forwarding chip and build devices that go faster and faster. So as well, right, the two gentlemen there, of course, the boys had to have some leadership. So they got Jayshree, the CEO, to actually help them run this company. And this all started in 2004. Our first product released in 2008. Another key thing here is, with all the experience from these three, Jayshree was the lead, the CTO of the data center business unit at Cisco as well. So a lot of industry standard or industry background from these guys. So 2004, Andy, Ken, Jayshree decided, let's start this company. Enough money to have, don't worry about releasing products. Let's build the system correctly from the start, right? Let's engineer the system to be better than what's there in the industry. And first product is in 2008, right? We did an IPO 2014, reached the S&P 500 in 2018, and today we are the second networking vendor in the world. So you can think, of course, right, Cisco's number one. Is it going to stay like that? I would say no, because I work for Arista, but only time will tell. You'll see some of the graphs just to give you an idea of where we are moving from that space. Okay, let me just get back here. I don't have a copy of what I can see here. So acquisitions across the last years. So you'll see quite a few names there. I'm not sure if you've seen these names in the networking space. The most important ones that I want to reference, Mojo is our Wi-Fi portion. We are switching experts, right? 2018, we had zero idea what an AP was. I don't even know. We didn't even have PoE switches at that time. So we acquired a company called Mojo, which now is Arista Wi-Fi. And then also the other interesting ones is VeloCloud, one of our latest ones, SD-WAN, Matomico, which is quite cool. It's a low latency, ultra low latency, like an ultra low loss, very similar. And then the other ones are Pluribus purely for software side, Big Switch for monitoring, and Awake for security. You don't have to write this down or worry about it. Everything's under the Arista umbrella now. So it's Arista NDR, not Awake, don't stress. Okay, so market recognition from our end as well is Gartner Peer Insights. So 2025 Magic Quadrant for Data Center, we are the leader in that space. We've been for the last 7-8 years. We are the most programmable or SDN vendor out there in the world by the Forrester Wave. and then also the customer choice in wired and wireless LAN for our products. So big market recognition from our side. Okay, this just shows this in a diagram. So you can see here, we only started doing campus in 2020-ish, right, 2019. So we've moved up right underneath the leader quadrant. Data center, I've said, listen, we are there for quite a long time. We are, like I said, we've been in the last 8 years in the magic quadrant for data centers. So no surprise there. I'll show you now why that is like that. Okay, so before we continue, the team. You can see myself there. That's me in Ethiopia, right before exactly such an event. Then also Olajide, or Jide for short, right? Covering Nigeria and Ghana. Then the other important people, that guy there at the top left, I don't like him, he's the manager. And then my other colleague, Werner, also a systems engineer. And then Philip, our PS engineer on the right-hand side. So this is the RISA team, right, for the Sub-Saharan Africa region. We are lean and mean. And it's just easy, right? Because the products actually work. So we don't have to have a colossal team to get the stuff running. So this is the guys, also Nathan and Asorgan. They focus on other regions. I don't think you'll see them. You'll definitely see Marius. I'll make sure he comes. And Werner also not. Sorry, Werner. He has Kenya and Tanzania to cover, so he has his hands full. Okay, so what happened? Right, we released switches 2018, right? What happened? You can see there's a massive shift in the market if you look at what was happening from a Cisco perspective. They were the biggest vendor out there, right? They are still massive, don't get me wrong. But in data center, we were starting to eat their breakfast, lunch, dinner as the years went along. And finally, 2023 Q4, we surpassed Cisco as the leading vendor in the data center space. So I want to say the main reason for that is due to what our customers experience by running Arista. It's reliable hardware, right? Open standards. But the fact is the market is seeing Arista and moving away from the other vendors out there, right? I'm going to say Cisco a few times here. That's our biggest competitor. There are others, right? The others as well, right? But you can see we have continuously grown our portfolio as we went along, surpassing them in Q4 in 2023. And then also, just some idea on investor confidence, right? What we do. So this is a 5-year graph of the Arista stocks versus, again, our biggest competitors out there. There was HPE. There also was, of course, Juniper. They have amalgamated into one company. But this gives you an idea of where investors see the market and the technology going. So you can see Arista 600% up in the last 5 years. The other vendors, they grew, sure, right? But the market really is, again, feeling confidence in what Arista does in our networking portfolio. Like I said, we are really not that far behind Cisco, so it's quite interesting times on what's happening. Okay, customer references. This one is always one of my favorites because people say, we've never seen Arista. You know, we come into buildings, we see Cisco APs. If you pick up your phone right now, anyone who has their phone open, right? If you're sending a WhatsApp message or browsing Facebook or have an iPhone and you have iCloud storage, have Office 365, using any one of the million of Google products out there, you are using Arista switches as we speak. So we are massive in the clouds. 6 out of the 7 big clouds use Arista. There's one cloud that doesn't. Anyone can take a guess? I don't have prizes, sorry. Next time I'll bring. Take any guess. It's not Microsoft. Microsoft is our biggest customer. AWS, there we go. I will give you something. I don't know, I'll buy you something else. So the only cloud not using Arista is AWS. Reason? They build their own devices from scratch. So they build their own hardware, they build their own software. It's doable, right? I mean, the chips we use on our switches, you can go buy it, you can put it in a circuit board, you can program it. It's not easy, but it's doable. So that's the only guys who don't use us. Any other big cloud out there is big Arista customers. And of course, then a bit more local, right? Ghana is a new region for us, so we don't have a massive footprint yet, but we do have some customers, including Heidelberg Materials, Garnet, and of course, our biggest one here is APSA. So APSA is a global account ran from South Africa. Pretty much any African country with an APSA in it has a Arista kit inside their network. Then other big ones, and ones that I actually do support. DSTV. I'm assuming everyone here watches DSTV, right? DSTV streaming. All Arista, I promise you, it's all Arista. Busiest network that I know, DSTV. Video streaming, multimedia streaming. It's a 1080p stream, 4 gigs a second, constantly, 24/7, 365, times 100 channels, 200 channels. Busiest network we have is probably in the region is DSTV. Other ones, right, more of my customers, Dashin Bank, Ethiopia. Ethiopia is a massive region for us. There's also service providers there. Dashin is the biggest enterprise one. And then, of course, we cannot have a session on AI without saying, listen, yeah, the AI guys also use us. Biggest push at Arista is, and biggest push for 800 gig, 1.6 teras, everything that Dinesh talked about is most likely those guys at the top right. Anthropic, or OpenAI, or ChatGPT, whatever you want, any one of their million products they have, biggest customers of ours as well. Okay, so where do we live, right? Where do we actually support the guys? So the main thing that we do is, from a support perspective, and I think this is different from the other vendors out there, is we have in-country depots. So that means that from a hardware perspective, if you have a failure of your device, power supply, fan, entire switch, and maybe it blows up, I don't know, hopefully not. I've never seen a Arista switch blow up, by the way, just to make it clear. We have in-country depots, so spare holding is done in-country. We ship it to you. You have an option of 2 hours, 4 hours, next business day RMA. Depot is just right behind the airport, so it's very easy and quick to get here. Maybe not with the Ghana traffic, as I realized on Tuesday, 5 o'clock. Took about an hour to drive 7 Ks. So yeah, maybe do the 4-hour RMA and don't log attack case in business hours or in busy hours. I'm kidding, of course, guys. They will fly to you, don't stress. With a helicopter. I'm not sure. Does DHL offer helicopter services? Well, they should. If they don't, they should definitely do that. Okay, so support across the board. Ghana's already a depot, right? If there's a country that we don't have a depot, we can spin up one in 6 weeks. So we have the ability to support our customers across the world. Software support 24/7 and 365. Our tech engineers follow the sun. So if you call early morning, this is GMT +0. If you call now, you'll get the MIA guys right there in Shannon Island. If you call a bit later, you'll get US West Coast and then US East Coast. You call early morning, you'll get the excellent guys from India. Some of our best tech and developers sit in India as well from our perspective. So the key differentiator we do here is that our tech centers, number one, all Arista employees, not third-party call centers taking your serial number, asking, okay, hold on, let's see, let me get an engineer. The engineer picks up the phone, is the guy who's going to help you out, number one. Number two, development centers sit in the same building as the tech centers. So that means that if the tech guys see, listen, okay, this problem looks buggy to me, I don't know, they can literally walk over to the developer. Mr. Developer, this doesn't work. Mr. Developer comes on a call. Let's see, okay, this doesn't work, my fault, fix it, done. Really, really low barrier to actually getting problems resolved. And we'll have a look at the next slide. There's a reason why our tech is considered one of our differentiators as well at Arista. And then training. Question gets asked a lot. I'm sure it's going to be questions on, how difficult is to switch, how difficult is to work with the devices. So main thing, Arista uses industry standard CLI, which is similar to Cisco IOS. I'm assuming, is there network engineers here work with Cisco IOS, Cisco devices? Most likely. I'm assuming most of them would be Cisco, right? Our CLI is very similar, 95% similar. It was so similar, Cisco tried to sue us for patent. They lost, luckily. Else I would not be here today. It's very simple. All the skills you have now is directly translatable to Arista Kit. And most of the engineers, even the SEs working in Arista, were CCIE certified or similar. So it's very easy to work with. But if you do need training, we have a full suite of training ranging from entry level to mid-level automation training and full layer 7, level 7 as we call it, development and design certifications available. Okay, so now actually let's have a look at what we actually do. I showed you where we come from and all the cool stuff that makes us Arista. So what do we actually sell to our customers? Now, funny thing, Arista is a software company. Yes, we sell you a switch. You get the switch in a box with a nice blue Arista sticker on it. But we are actually a software company. As I mentioned, the company started with Merchant Silicon. I did not mention that word, but Silicon bought from Broadcom, Intel, all of these guys. We build the software around that chip. So we are inherently a software company. So most of our things that we do sell is, of course, the hardware, right? But the software that runs on top of it, the software that does the features, the software that makes the magic happen. We are the only vendor who's done software, Merchant Silicon from day one. So I can safely tell you, we are the leader in running with this Merchant Silicon devices in the network. Other guys are also doing this, but again, they are not on the same level as what we do with these chipsets. So number one, crown jewel, operating system, EOS. This is what does all the magic. Now you plug in your LAN cable, you take the nice Cat6a, you plug it into your laptop or on the AP. This is what runs that software on the switches. This is what gets packets from A to B. This is what gets you your YouTube video in 4K HD quality. Our operating system runs across all of our switching platforms. And key differentiator is that the same operating system runs across all of them. I'll chat about that a bit later. Agni, network access control. So again, you take the Nexus cable, you plug it into the switch, but who says you're actually allowed on the switch? So Agni is our network access control portion, right? That is NAC for short. It tells you, user Mikhail is part of the organization. Yes, he is allowed on the network, or he is not allowed on the network. Or he's allowed on the network, but he's been naughty. Put him on the naughty list, so you can only do work, no YouTube videos at work. So that is the network access control. From a security perspective, we have network detect and response. So that is where you actually monitor the wired and wireless side for looking at threats from a security perspective. So that is NDR. It runs on the campus switches. It runs as a completely separate from Arista product as well. So security focus. Monitoring focus is the DANZ monitoring fabric, or DMF, a network packet broker to push packets and have full visibility of packets inside the network. And then to top it off all is our one and only CloudVision to actually help you manage this entire solution. So all software products, yes, you do use switches to run on them, but they are software inherently, and that is the key strength of Arista. All of these supported by our one and only TAC. We don't have different TACs to do this. It's a single TAC powering all of these technologies. Okay. This is Arista, right? This is the physical portion of Arista at least. So you can see this quadrant is our, we call this our general slash, heavy duty slash normal quadrant. Left-hand side, you'll see general products. Think of data center, think of campus, right? These are the normal products we sell. 90% of what I propose to customers is part of this portion. On the right-hand side, we also have specialized. So these are specific use case products, high root scale, service provider device products. Also looking at the AI networking, that is the right-hand side right there. High density, high demand products. Normal products, the normal cool stuff that I also like. Those are cool, but these are also cool. So if we look at the use cases, like I said, data center campus, right-hand side, service provider, AI, and then also ultra-low latency switching right there on the right-hand side. Interesting product. just for interest sakes, right, it is like a physical wire connectivity. So if you need very high speed connectivity, or low latency rather, between two devices or between two systems, 5 nanoseconds to get your packet from one side to the other. That's crazy fast, right? That is ridiculously fast. Used in trading. I don't think it's used anywhere else really. So that's on the specialized products. We also had a fully programmable switch on the right-hand side, which you can actually modify the packets, push them certain ways, do all kinds of funky things. But that product, unfortunately, has dead. Okay, top-hand side, bottom side. Bottom side is fixed. Top is chassis. Same chipset. Let me take the pointer, not walk around. Oh, that doesn't help at all. Fixed chassis. My job is easy. I talk to you. What do you want to do? Okay, we want to build XYZ. Okay. What size? What scaling? 100, 200, 400 ports, 1,000 ports. Okay, we can go fixed. 10,000 ports chassis. Biggest benefit of Arista is that all of these run the same operating system. You don't have to worry about it. These are the same chipsets. That just scales higher. That's all. You don't have to worry about which one to choose. What's the scale you'll need? Small or massive? That being said, most of our customers work in this space. Reason is, I would say in this size, one RU pizza box, 32 times 400 gig interfaces. That was 2 years ago. Today, pizza box, 32 times 800. 2 years time, when I stand here again, 32 times 1.6 terabit. So the amount of density you can get in modern devices, one RU, is ridiculous, right? It is massive. So most of our customers choose fixed, especially when you build something like a leaf-spine network. There's no need to go for the chassis. But we do have customers that use them. Okay, so where do you use Arista? It's very simple. I don't want to say anywhere, but anywhere where the network is critical. Comes back to the Wi-Fi question on the AP. You know, why run 2 LAN cables? You see, networks is not a nice to have anymore. It's critical to how we do business, critical to how we communicate, critical to how we alarm anyone, critical for development, right? We're sitting in engineering space. I mean, I had a medical customer now saying, listen, we need to push medical scans, CT scans. Each and every scan is about, 100 gigs. It's like, okay, not a problem. Let's do it. That is where we are. These are critical. Networks are not just nice to have anymore. They're critical across all aspects. So, looking at the different references here, data center, absolutely, this is our bread and butter. We're talking about normal data centers, connecting to data centers together in a secure way, as well as NAV, one of my biggest use cases in Ethiopia. Campus networks, again, layer 2 networks, Wi-Fi, wired, security. That is where you would use Arista in these spaces. WAN side, so we also have quite a big WAN or SP side customer base. So, MPLS, segment routing, peering, very big use case for Arista, customer aggregation, and also SD-WAN. And then AI networking, our new bread and butter. Any AI networking, as you can see, Dinesh again said RDMA. He's saying that InfiniBand's the best. I'll beat him afterwards. We don't do InfiniBand at Arista. We hit you. If you try to do that, it's Ethernet or get out. Done. So RDMA, remote direct memory access, that also works over Ethernet. I just want to make sure. Rocky, yeah. I'm still going to beat up Dinesh afterwards. Just look away, everyone. So Rocky, RDMA, AI inference. So honestly, like Dinesh mentioned, right, the big clouds are building the AI networks. They build these massive, colossal clusters that you see, when you hear the news, 10 megawatt data center with 80,000 GPUs and how much network. That is for the big clouds. What we see here in the smaller regions is AI inference training, right? So that is a smaller AI cluster which helps you with your specific demand. It takes the training from those big guys and specialize it down to your use case. This is where we'll see AI in Africa, honestly, right? I don't think anytime soon we'll be building a massive data center for AI specifically, but that is a good space as well. And again, the great thing about all of these use cases is this crown jewel we have in the middle. All of these use cases run a single operating system, same CLI, same management platform across the board. Fundamentally, what it means is, if you're a customer there at the campus side, you buy a 12-port PoE switch, you're running the same operating system that Facebook is running to do all the AI. It's actually kind of amazing. So you get the same power, the same testing that these guys do, you get it in your campus switching. Fantastic. Okay, our architecture blueprint. So I'm not going to go into too much technical detail on the architecture, right? We can always have a session afterwards. I'm pretty much here till tonight. So what you see here in our designs is what we see as a leaf spine, right? Spines at the top, leaves at the bottom. The reason why Arista, not believes in a leaf spine is due to the flexibility and automation it gives. It's a repeatable cookie-cutter design, works in most use cases, it's not mandated, works in most use cases, and allows us to kind of put all of these different networks together in a single unified design and automation platform, right? It's very simple to work with. Leaf spine was becoming popular 2012. We actually one of the first guys to push or to work with Microsoft to build some of the world's biggest leaf spine networks. And you can go to any vendor out there now. I'm sure if you go to Cisco, Juniper, whoever, they will also be proposing leaf spine. It works, it's scalable, it's automatable. It's the way to go. Again, not mandated, but highly, highly efficient. So what can we do with this leaf spine, right? What's all the use cases of Arista? We touched on them just briefly in the previous slide. WAN branch edge, smaller sites, smaller campuses, branches for banks, for enterprises, DCI, DC routing, connecting two data centers together, data center workloads, right, of course. Campus networking, interesting again, and you see the NDR, a bit blocky, but on the NDR side, the devices can also run the agent for security, allowing you to see east-west traffic. Biggest problem with branches and campuses is that your security tools sit at the top layer. You have to force the traffic to the security tool. If my laptop is plugged into a LAN port here, and I try to access something right there on the same switch, from a security perspective, you will never know that I'm trying to attack the network internally. That's what the NDR detects and looks at from when we look at this space. Prime example, what the NDR does. You have 100 IP phones, all of them is talking back to the call server, one of them is trying to go to Google Drive. Why? Why is one device doing that? And that's where the machine learning and AI from the NDR platform comes into play. It tells you what is different from your devices in your network. And then on the right-hand side there is the packet brokers. This is quite a niche product, right? It copies traffic from this production network into a set of tools. The tools could be network monitoring, it could be an NDR sensor. You can analyze the packets, you can record them for important, for security reasons or for just monitoring side. Network monitoring, performance monitoring, security tools. This is fundamentally, again, the all Arista stack. And at top level, you have the application on the software side, which includes management of the campus portion, NDR, Agni, Uno, which is the observability product, and the DMF, all pushing data to our one and only Cloud Vision at the top. Okay, another thing that we also do, we always think at scale. So this is a Wi-Fi solution. How we've done Wi-Fi is different from what you typically see from the other vendors where you have a dedicated controller on site. Our Wi-Fi runs in a controllerless architecture. That means that there is no centralized controller. You're not forced to push the traffic back to the controller and then break it out from there. We have the ability to local breakout users in specific VLANs and also tunnel users in an open standard back to a central space if you need to do that. So scaling from our Wi-Fi solution, we actually released a new software innovation on our side. We call it Vespa. I'm not sure if you guys know the Vespa scooter. Don't know why they called it Vespa, but it allows colossal campuses. Think of universities running 50,000 users, these massive scaled environments. This scales at that level, and the Vespa portion scales all of that. So big focus on scale. Biggest Wi-Fi customer we have in the world, there's 3 of them. Biggest one, Reliance Jio, 270,000 APs. Comcast, I think, is about 200, and then there is also, I think, Google, about 110,000 APs managed by a single web interface. It's crazy scale. You can also have one AP, really. Don't have to have 100,000. Okay, and then the key thing, right? I'm hammering on single operating system across the board. This allows us to have, in all the use cases, different use cases we have out there in the world, public cloud, campus, data center, WAN or branch, and internet core, all of these different use cases run a single operating system. All of them is streaming, all state streaming telemetry back to a central operation platform called CloudVision Portal. So this gives you the visibility across all different fields. Again, not something you'll see from other vendors. They have different operating systems, different management platforms across the space. We have a single one in this, in the Arista portfolio. Okay, this is just a quick slide. I'm not going to go into this too much detail. This is a slide on our management platform, CloudVision. So what I want to showcase here is that it is a platform that helps you start automation or have a full automation pipeline working. So if you have CloudVision Portal, right, you can start out by just pushing a VLAN to 20 devices, simple configurations. Or you can go all the way out on an automation journey, right? Middle one is have a GUI to configure entire data center. Final one is where you have a guy spinning up a service, spins up a server as a service, configures the network or on a pipeline, and CloudVision helps you do that from A to Z. Okay. Final topic, right? What differentiates Arista? So looking at the 3 key pillars we do, right? Number 1 is we work with the world's biggest clouds. So what we see is, what they do is they try to automate as much as possible. When you have everything automated, very little can go wrong, but stuff still do go wrong. Azure has been down, AWS has been down, Google Cloud has been down. So how do these guys actually react when that happens? And that's the key difference that they do, is they look at the telemetry and analytics of networks. The things that we do, right, is we stream every single thing that happens on a switch in real time back to our management platform, or in the cloud's case, their own one. So these guys just react to failures way quicker than we do. So key thing is automating, and then also having visibility to react if something does go wrong. So that's why choose us. Next up, superiority quality, right? So superiority quality, hardware and software, leads to lower total cost of ownership, less time spending, wasting, fighting fires, doing mundane tasks, and just more time actual engineering, building, thinking what's next, thinking what's ahead in the space. And then finally, if something does go wrong, we also support our customers with world-class support with a +87 NPS score. If you don't know NPS score, you're lucky, but it ranges from -100 to +100. +0 is good, +50 is great, +70 is world-class. We are sitting in a +87. You're welcome to compare to the other vendors out there in the networking fields. They are not close to that. On top of all of this, a modern architecture which is scalable, programmable, and standards-based. We don't do proprietary lock-ins. Our customers are locked in by good quality service and good products, not by some protocol that you can't get away from. Okay, I'm going to skip that one. So in this aspect, right, just to show you that what Arista believes from a software perspective directly boils down into a security perspective. So focus on software of CVEs you see in your networking products. So from Arista, you can see that's a 10-year cycle, so 2014 to 2024. It has Arista and all other vendors out there. A CVE is a common vulnerability and exploit. It's a publicly listed exploit you see on your devices. In 10 years, Arista had 30. Now, if you have a look at the competing products, this is not to vendor bash anyone. It just shows you that in 10 years, other vendors had 954 CVEs. So in 10 years, so let's say divided by 10, right? 3 CVEs a year. Divided by 10, 95 CVEs a year. That means that you as engineers need to go and look almost every second or third day, okay, what's this new CVE? Do we need to upgrade? Do we need to spend our time to fix the stuff? That's waste of your time, right? That's not how things should work. It should run, it should be secure, and this just proves again that software quality does directly boil down into the hardware side. Quick slide on the NPS scores. Not going to read this, but you can see there plus 87. Customers highly regard our support as superior. And then also from a campus perspective, this is our customer's choice. So we are considered as a customer's choice for wired and wireless networking. Like I said, this is a new market for us. So we are seen there on the top right-hand side as a customer choice or preferred vendor in this space. My last slide, I know everyone is tired, it's lunchtime, so I'm going to be very quick here. So, why Arista? Best in class, highly available networks, right? That is our focus. We build high performance network for our customers, and this fundamentally helps you to eliminate planned downtime and absolutely reduce unplanned downtime. So also with our zero touch and automation capabilities, we'll improve IT efficiency typically by 3%, and then looking at something like zero trust networking, we will reduce our threat surface by 60% if you immediately already deny users moving laterally inside the network. Okay, any questions? Please.
Hello. Thank you for your wonderful presentation. I think some of my questions have been answered as you went along. It looks from your presentation that Cisco is your main competitor. My first question is, do you have any issue with interoperability? If I have X amount of Cisco equipment, because of this new information I've gotten, I want to start playing with Arista.
Yeah.
Do you have any complications? I just want to know that you can work with other vendors. That's my first question. Do you have indication for, let's say, mean time between failures? If I buy one of your 7200 equipment, what is the likelihood of its failing? In Cisco, when I buy 4500, I know all things being equal, at least 10 years is solid for me. So for me, if I'm taking a decision, this is one of the things that will inform me. My last question is, what about the price? Even though I saw reasonable TCO, you mentioned that total cost of ownership is going to be great. What costs are we talking about? And finally, do you have vendor, somebody I can play with immediately from here to test? The reason why I've asked these questions are, I've worked with British Telecom before, and interoperability is a major issue.
Yeah.
And I'm coming from University of Ghana, where we have about 90% of Cisco. But I'm happy to see that Garnet has started using some of your boxes. I would like to know if you can answer these questions to give me some peace of mind. Thank you very much.
Those are all good questions. I will just need to make sure I remember. I might ask you for question 2 or 3 again. Number 1, first question was the interoperability. So this question always pops up, right? How do you work with the other vendors out there? We are fully open standards based, meaning that if you support open standards, we can interoperate with whichever vendor there is out there today. So a good example, let's take a prime example, seeing as you mentioned Cisco. If you're running EIGRP inside your network, right? That is Cisco proprietary, it was. They made it open standards. No one ever implemented it because it's a Cisco protocol. OSPF is very similar. You would need to have a gateway to convert that to OSPF. Not a gateway, just a redistribute into OSPF. So interoperability for us is a key thing. One thing, right, the big clouds would not be using Arista if we weren't interoperable. That's very important, to understand. That being said, I have a lot of customers, especially if they have estates, they would maybe replace the distribution with Arista, keep the access, Cisco, because the stuff still has life, right? Doesn't make sense to rip and replace. So we're also very good, we interoperate very well with other vendors in the space. Okay, second question. Geez, my memory is bad. Just quick. Okay, meantime between failures. Let's talk about actually life of products, and then we go to meantime before failure. So we do publish our MTBF factors online or values online. Yeah. You can see the meantime before failure for switches. I would say it's difficult to believe the sales guy in front here, right, saying this and this stuff doesn't fail. We do have failures. Everyone does, right? I'm sure if you're Cisco equipment, Juniper, whatever equipment you will have. But the main thing is we have switches I've seen switches that run for 11 years, no problem. A good other factor in that discussion is, how long does the product live? Because you mentioned if you buy a device, next 11 years, you don't have to worry about it. So any one of our products has a 5-year support. If we do end of sale on a product, there's still 5-year support. So that being said, even if you buy an old product right now, it goes end of sale, you'll still have 5 years of, supported life on it. But a lot of our customers, right, they will run the switches until they give in or they're too slow. I've had, in my career, I've had very little switches actually come back from RMA. I've had some, yes, I do. But it's low. It's quite low. I have a slide in some deck. I can show you, the actual amount of RMA you'll experience. It's very, very low. I can find and I can share it with you for later.
All right, okay.
There was 2 more questions. Number 3 was TCO, costing. Always a fun question, fun discussion. So one thing to notice, right, we are not we are a premium vendor. So our equipment is not cheap. It's not cheap equipment. It is premium product, runs in the world's most reliable networks. So that being said, right, if you're going to go apples for apples, we in Cisco can fight on discount levels and, it's going to be just a race to the bottom. Doesn't make sense. Where we really do focus and win is on modern designs. So going from just looking at the design, going one step back, looking at what you have, how we can design this, how I can do this differently. That already, if we go from a typical chassis, right, to a leaf spine, customers already see about a 30 or 40% saving from what they would have paid from a chassis solution. So I would say it really goes down to design. The other thing is our switches, this is overlooked. Dinesh again mentioned this in the AI networking. Our power utilization on devices is almost always lower than the competitors. Remember, if you take a switch out of the box, put it in the rack, you turn that thing on. It's not going to turn off for the next 7 years. It's going to run. You're never going to switch that thing off again. And that counts up, right? Especially in, again, the AI networking space, we have a lot of innovations to actually reduce power. They are using so much power, there is no power left for the switches. And that's where we also shine, in the AI specifically. But in any one of the other designs, we save you with, number one, less issues on your network, right? Reliable design patterns, reliable networks, lower TCO. Your engineers doesn't need to sit after hours, doesn't need to run around, doesn't need to fight fires. The devices have a long life and they work excellently for the life of the device. So TCO is a quite complex discussion. The price you see at the start doesn't mean what's it going to cost with the support. How many engineers do you have to run the network? How many times you need to pay a guy overtime to sit 2 a.m. in the morning and fix silly mistakes? Okay, there was one more question. All of them. Okay, cool.
Right, okay. So please, do we have any other question?
You are welcome. Sorry, you're welcome to also ask full technical questions. I might have a slide or 2 on something technical. Okay. If you were looking for something more interesting.
Right, okay. I don't see any other hand up. Any question, please? Okay, there's one there for you.
looking into the future, based on your presentation, your growth primarily were based on the hyperscale users. The environment may be fluid. In terms of any challenges with any of them, you will just come down all of a sudden. Because if one drops amongst your major users, if any of them should drop, your growth will be challenged. And looking at your growth projections, it looks like you are growing so fast. And surely you might also come down so fast.
Jake, you want to take the knife, put it in here.
And looking at the geopolitical, I mean, challenges with the silicon and the likes, what is the way forward? How sustainable can you be? Like the Cisco's who have been in the system for quite some time now.
Yeah, that's actually a fantastic question, right? And definitely something that our COO would love to answer for you. But let me take a shot at it, right? So that's a reason why we are diversifying. So campus for us is new. Campus is a massive, massive business, right? So most of our wins these days, modern wins, especially in not big data centers, is campus customers. So Arista's vision now is AI and campus. That's our focus. Data center, we've kind of won, right? I'm sorry, Cisco, we've won the business. I'm not being rude here. They are very upset about that, by the way. Speak to your Cisco AM and ask him how happy is it that they've lost to Arista as the leading vendor. They will love it. That being said, so campus and AI is where our big bet is. We are growing in the enterprise. We are organically growing there. But campus, there's a massive amount of space where you can still grow. If you want to buy shares, I'm assuming that's what you're asking. So it is dangerous, right? I always tell someone who asks me, personally, not professionally, is that we are kind of on the AI bubble. We don't directly participate in AI chipsets, but we do build the networks that run those stuff. If AI falls today, we're going to go, we're also going to take a massive dive in the stock pricing and what we do. That's just the reality of it. But in all honesty, with where AI is today, I actually have a video on my phone. If you look 3 years back, I'm not sure if you ever saw the video of Will Smith eating spaghetti, the AI video of Will Smith eating spaghetti. Have you seen that video? In the start, it looks like the spaghetti is coming out of his nose and it just looks not right. Today, you can ask any one of the AI generative portions, listen, give me a video of Will Smith eating spaghetti in a restaurant in Italy doing this, that, standing on one leg, and you'll get a perfect video of where we are. AI is not going anywhere. It's just going forward. The chipset shortages, the RAM prices, all of that, unfortunately, I like gaming, so my gaming computer upgrades will need to stay away. My new laptops will need to wait because the pricing is insane. I don't think we're going to stop anytime soon on AI networking. If that's good for humanity or not me to decide, but we're not going to stop there anytime soon. And again, I know Dinesh mentioned InfiniBand. NVIDIA loves pushing InfiniBand for their network because then they can do a full NVIDIA stack end to end. Ethernet, at scale, Ethernet has won that battle. Smaller deployments, and Dinesh, you can also tell me, smaller deployments, InfiniBand makes sense. Bigger ones, what the clouds are building, it's Ethernet. So I still think we have a long future ahead of us on the AI space. But yeah, our bigger focus is campus. If you talk to our CEO, focus is campus, AI. Those two is our big focuses.
Right, thank you very much. I think there are a few more questions and then we'll be rounding up very soon.
Yeah, so Dinesh mentioned this, and this is exactly the case. InfiniBand is vendor lock-in. So NVIDIA can sell their switches, their GPUs. The only thing I can't sell you is the servers, but they sell you everything else. So they make, obviously, way more money. InfiniBand is expensive, like proper expensive. Like if you thought you had money, go get a quote on InfiniBand, and you'll cry. You understand you don't have money.
Thank you. Lovely presentation. From the beginning of the program, you guys are a software developing company, right? And I saw the airport and also Kenya Railway. but I can see, I haven't heard anything about like transportation. So I wanted to know how do you develop, like, let's say, with your transportation, let's say something like railway, you know you need an OCC, and the OCC is something that controls the trains. When the train moves, when it gets to the crossing, there's a boom that needs to drop for vehicles to stop, for the train to pass. And you know, Ghana currently, the government is really channel his focus on the railway industry. So I want to know, mostly with railway, Ghana per se, I think we don't have something like a software. So mostly I think we adapt from either Germany or other countries. So I wanted to know, like, how best can you guys help Ghana, our railway system, to develop our own, let's say, network plan? Yeah, thank you.
Okay, interesting question. So let me just think about this, because when looking at these systems, and there were some references in their slides, we also did Kenya Port Authority, right, which is, it's not trains, but they also do transport, bring stuff together. If you're talking about the networks that connect these things together, that Arista has a space there, right? That's where we play. We have industrial switches now as well, our space, so you can place them all around the country. Obviously, you need to have fiber running there, but at least in South Africa, the guys or the train companies, they run fiber alongside the railways. So there's transport available for running, data connectivity to these sites. If you're looking at like very specialized industrial applications, that is a bit, that's quite specialized. Like Kenya Ports Authority, they ask us, listen, can we do the Wi-Fi on the edge where they are loading the containers on top of that? And I'm like, we can look at something, but that's not what the Wi-Fi that we do is. That's not what it's meant for. The Wi-Fi we do is for offices and guys sitting here with devices. That's a specialized system they have on their end that does that typical mesh Wi-Fi networking. It's not standardized. It's something specialized they do in that space. So the short of it, right, is we can help you if you're looking for Ethernet connectivity. In that aspect, you want to transport traffic, you want to have a data center where you run these systems and operate and monitors this. But if you're looking at, specialized products that drop booms and doing that, that's unfortunately not our space. Does that answer your question? Sorry. I was hoping I could say, yeah, sure, we have everything, but no, we don't. I can give you 100 gig to your train. If you want to stream again YouTube at silly, ridiculous resolutions, but that's where it stops. Any other questions? Or comments? Yes, you had good comments on the future of AI.
Hello? Yeah, great. So I'm guessing that if we don't have questions, probably. Okay, is there a question or contribution? A comment, right?
I'm looking at the Ghana Building Code. It's being updated, and it gives me some experience I'm getting currently. I'm receiving a building that was started in 2007, and it's being completed now. Obviously, if we had the opportunity to update the design, obviously we'll be looking at using these current cables for the lighting and things like that. But obviously 2007, and the consultants and the contractors are using design everything from 2007, and we are receiving it now. It doesn't conform to the current standards that we are updating, and then we don't have the opportunity to make it smart and perhaps more efficient to run. So I know there are a lot of policymakers from the ministries. These are things perhaps we should look at. When the old buildings that are now being refurbished or that are now being completed, is it possible that we could look at updating the designs to conform so that we can make them a little bit more smarter than we are currently going to receive them. I'm receiving this building maybe next week, about 2007, and the electrical wiring, the standards, the internet facility, everything is from 2007. And as someone who is receiving it now, I wasn't involved in the current updates to the building. So it's going to be finished, and I receive it now. I have to get internet facilities into the structure. So perhaps these are things we can take away now that we know these things. Thank you.
Thank you very much, sir, for your contribution. One of the things that was missing throughout today's meeting or engagement is the fact that even from the contributions that came from the participants, we really did not get to know ourselves very well, right? I mean, we didn't get to know the names, we didn't get to know the institutions we come in from. Am I correct? Oh, is that not correct? Great. So this is a quick roll call. How many of us are coming from government institutions? Just show by hand. Just by hand. Government institutions. Wow. Okay, and how many of us are coming from academia? Academia? Okay, and how many of us are coming from the telecom? Any telecom? Any telecommunication? Right. We have a lot of engineers in the room, I know that. Right, okay. If there is any other probably sector I haven't mentioned, so what we want to do, first of all, is to give it up for Thom for his presentation. Thom, thank you very much. If there are no further questions for you, you can humbly take your seat. Yes. And then the next thing is to take this sheet. Right. Everyone is having a copy. Take this sheet. That is the event feedback form. We want to quickly fill the event feedback form. Right, so the category of participants I was asking for is actually highlighted here. Yes, we want to take feedback from you. So you indicate your institution. From the first matrix, you can see we have a name, organization, position, email, and then your sector. The name is optional. You can put it there, or you can leave it, and then you complete the rest for us. This should take us about 5 minutes for us to complete, or even less, 5 minutes. If you're done with yours, you can, the protocol team will help us, yes, collect. The protocol team will help us collect. That unfortunately, this conference was supposed to actually span across a number of hours. That is, we were supposed to do lunch and come back. But then we thought it wise that we could actually run through everything so that when we take our lunch, we are out of here. We know today is Thursday, there are a lot of engagements for most of you, and we wouldn't want to take all of your time. Yes, so for the comment on lunch, I know you will leave it blank. Yes, it was designed for the original schedule of the program, yes. So please, if you're done, the protocol team will help us. You put up your hand, and then they will take it. Great. Right. And I have one important assignment to do before I step down. Right. Great. Mr. Jeffrey Handel, please, can you join me up here? Yes, I know this one. I have the opportunity of putting him on the spot. He is not aware of this, yes. But Mr. Jeffrey Handel, like I said, is the CEO and MD of VHF Solutions. He is going to help us do a presentation. You're going to help us do a presentation. And this is to acknowledge and really say a big thank you to Ghana Institution of Engineering, because they opened their doors to us. They made it possible for us to come in here and have the opportunity to engage and discuss on these salient issues that will affect the future of our country. and we want to say a very big thank you to them. So, a presentation, we have something special for Engineer Sophia Tijani. Is she here? Oh, please give it up. Give it up. Is she here? She is the president-elect. The president-elect. Please, anybody who can take it on her behalf? Anybody to take it on her behalf? Right, okay, so that is a beautiful presentation. So, doing us the honor by taking this on behalf of the president-elect is Engineer Shaku. He is the branch chair for branch 5, yes, of the Ghana Institution of Engineering. Thank you very much, sir, for doing us the honor. Yes, and we want to say a very big thank you for giving us your space and also partnering VHF and Simon to make this possible. Now, the next presentation, and to help us will be Mr. Rodriguez. Please, yes, please let's give it up for him. Let's give it up for him. And this special, oh, okay, great. Thank you very much. This beautiful and special package is to a man that has been very supportive. In fact, I walked in here without knowing him, but I sat down, I scanned through, and I knew, like, no, this is the man to talk to if you need anything. Please, participants, help me. And welcome up here, Engineer Atto Roberts. Engineer Atto Roberts. He's been instrumental with the planning, execution, making it possible for today's conference to actually come to life. We thank you so much, Engineer Atto Roberts, for making it possible, for the instrumental role that you have played. Thank you very, very, very much. Now, with that done, the next thing, please, are we done with the forms? Are we done with the forms? Right, great. Thank you very much. That was a quick one. When the CEO, Mr. Geoffrey Handel, was giving the welcome address, he made mention of the fact that we all have been invited to tomorrow's event. It is the grand opening of the office of VHF Solutions. The location is at Asylum Down, opposite Latter-day Saints, right? Yes, Asylum Down, opposite Latter-day Saints. So what we are going to do is that, please, the invitation is to all of us. The invitation is to all of us. At this grand opening, it is going to be a very short ceremony, 10 a.m. in the morning, maximum 1 hour, 1 hour, 30 minutes, we are done. Maximum 1 hour, 1 hour, 30 minutes. So we know that, fix us in your schedule. We want to see you there. We'll be happy to host you. Yes, so please make your way to VHF office that is located at Asylum Down, opposite the Latter-day Saints. For specific directions, we will be giving out a number that you can actually call if you don't know where Asylum Down is. Don't worry. I think from here, maybe about 30 minutes or less, right? Or 20 minutes drive. About 20 minutes drive from here. Yeah. 15. Okay. I know the engineers are calculating. Maybe somebody will tell me 17. All right. Okay. So yes. 20-15 minutes drive from here, you will be there. And we want to have all of you for this grand opening. Yes, on display will be a lot of gadgets so that at least you have first-hand information of what we do, the gadgets that we also have on display. Of course, some will be from our partners, that is Arista, as well as Simon. So please, we want all of you to be around so that we can actually together make this a grand opening as it should be. And thank you very much for your time. Before I sit down, my name name is Reynolds of Kwapon. I have been your moderator saying thank you. But before I do that, I would hand over the microphone to the chairman. He gave us an opening remarks, and it is proper that we hear from him at the end of the day. Give it up for yourself and give it up for the chairman, even as he comes up. Oh, the chairman is not here. Engineer Eric Insako, right? Yes, initially when I came in, I didn't get the full name, so please forgive me. I introduced you as Engineer Eric at the beginning, but now I have the full name, so it is orderly that I put it out there. Engineer Eric Sako. Please let's give it up for him again. He's been a wonderful chairman. Right. So we will take the closing remarks from him, after which Engineer Ato Roberts will give us the vote of thanks.
Thank you very much. So my task is so easy because the communicators were so strong, clear, and effective. So I will just harp on a central theme that ran through my mind as we engaged with them, starting, of course, with Jeff Handel. He has the phenomenal task of anchoring all of this into Ghana and perhaps by extension West Africa and the Sahel. But I think what ran through my mind was that as Siva was presenting, I was seeing companies that I also have worked for or can relate to. Main One, Stanbic, MTN, Ghana Civil Aviation, Bank of Ghana. So I thought that the generations typically are moving also in the direction of Genza Energy and Jospon and Maripoma, and there's a new economy being created, but you see from the list I'm giving also that Jeff understands why I'm smiling, that there's a certain general category that I'm mentioning, which has become as though my generation did not work in those companies. Now, a lot of the economy is controlled by those actors, and it's going to be interesting to see how all of this can be a journey we embark on together. Because I feel as if the adoption by the people who control most of the resources is a modernization of the whole society. And that informs us in this 4-quadrant, I love those 4 quadrants, by the way, campuses, AI, and the other 2. I love the way that they were put together. I found out that Prim Rodriguez is from Goa, and I love the catch-up that we had just before this. I think the big learning that I take from that conversation is the whole architecting of the reference work that how do you pronounce it? Simon has done across the world. Now, once, to the point that I made earlier, once we properly architect that, we are going to be able to express this story in the kind of language. I told you that I did most of my career as a CIO, but the period where I was not a CIO, I was head of sales and distribution of MTN. And in the conversation around mobile money and fintech and the adoption of smartphones between 2014 and 2021, and so on and so forth, the expressions that we loved in the boardroom were expressions around world-class competence into local problems. So that's the message that it will be a challenge for all of us to connect now, that we've done all the work right from Amazon to Huawei to everywhere else, but we need to see how this can properly express in the local environment. I enjoyed listening to you, Dinesh. I love a man who walks across and picks this cable that is not labeled and can talk about every color that is a feature of the cable. And at the same time, you look very comfortable in boardroom discussions as well. So I think that's almost every engineer's dream. At the point I heard him saying something about Z plug in a faceplate, and then, whatever level of detail you want to go to, I meet you there. But then whatever summary level you want, I also summarize with you. And I've learned so much, but I think we really need to see how people like Dinesh can also be created locally, because it's a big missing link. Most vendor presentations at big boardrooms and so on are tiring for executives, because they feel they are talking to a salesperson who sounds technology neutral to some extent, and then there's a big fear that this thing is going to be botched because they cannot see the person who's delivering. And then when you see the work crew does not want to have anything to do with business discussions. So the creation of a Dinesh or a number of Dineshes is a big challenge for every country. It releases the money. You see, for me, that's the important thing. I talked about the companies that have a lot of the money in the economy today. And you will be surprised. One of them, who's in upstream oil, I met them in telecoms. They were trying to diversify to telecoms. And you will be surprised the sums they were signing to vendors, because they didn't understand what needed to be done, and they had the money. But unfortunately, they did not get a good solution because they didn't have people who go between. They were not able to build that bridge. So the last presentation, you are Michael, I thought. Mikkel, okay, because you called him Tom, so I got lost a bit. But yeah, I love to see, while you were showing that last page, I was looking at the competitors you were mentioning, and honestly, well done to you guys. I mean, you are up against really big financial giants, and in your presentation, I'm sure a lot of people watching would assume that the revenues are even comparable. But if you see the impact of the innovation, the impact of the market share in the data center space, and data centers was one of the four I was trying to remember. But I think it's a really big story of being able to make a huge impact in a very competitive landscape. And I think, again, that this goes to, I don't remember whether it was Siva or Prem who said about 400 patents had been created by Simeon. And that is their aspiration, again, that the innovation comes through and we are able to do something with it in order to be able to scale. So all in all, I think it's been one of those wonderful sessions where we've all gotten a lot out of it. For some reason, today in particular, Ato, maybe you might help us explain, female participation is very low today. I see one or two, but normally it's about 40% or something. So maybe, Jeff, that's a challenge for you, if you can make the products a bit more appealing across the gender line. But thank you very much, all of you, and thanks for having me.
Thank you so much, Mr. Chairman. And just to say a few words, and one of the things that he said was building the personnel, and capacity in the institution and in our industry as well. I think we are at the point where, as engineers, we need to build new skills. and move across some of the channels so that we can be at the table and be able to speak to some of the issues. So thank you so much. And I stand here from the institution's angle to say that this has also been a very important session for us, because what is happening is that as an institution, and one of the main objectives that was set by our president was to try and establish 2 new divisions. What we have is that we have 4 divisions, which is traditional engineering, mechanical, chemical, civil, and then electrical. But we've had a lot of agitation from our ICT folks. It's quite a great number. Eric has always been at the forefront. There are several others. Francis Boachi, who spoke from Legon, he's actually my senior in electrical engineering, but he's been in the ICT space for so long. And so there are several of us. Tony Geto is one of the others as well. So we know that eventually one of the moves that will be made in the institution is to create an ICT subdivision, because the issues that we've spoken about today, you can see that it cuts across several areas, and we need to do things that will give focus, to that work that is being done. So we are grateful for this session, and we are grateful to our partners, Simon, Arista, VHF. We have conversations on many levels, and I believe this will not be the end. There will still be a lot of engagement. So thank you all so much for partnering with us. One of our members was saying that we need to make it an institution where we do it regularly. Probably every year, as things change, we will need to get Dinesh back to come and talk to us. So I believe there are several platforms that we can use to enhance this form of collaboration that we are having. And so just to end it off, thank you also so much for being with us through the day. It's been a long session, but we still have almost a room full, and we thank you that you made the time to spend with us. Thank you so much. For our next activity, we hope to see you also to be a part of whatever we'll do. Thank you so much.
And thank you very much, Engineer. So, on that note, we'll draw the curtains down for today. But before we do that, there's a last group of people that we haven't acknowledged, our online participants. Yes, our online participants. We want to say a very big thank you, because a few people that I even didn't know started sending me messages. Yes, that is when I was like, oh, that's great. So yes, probably we're not able to take your questions, but we believe that from every interaction that has gone on here, you've had a bit of knowledge upgrade. You've learned 1 or 2 things. We believe that we can always reach out to Simon, you can reach out to VHF, Arista, and all the partners, particularly the Ghana Institution of Engineering, if there is any need at all. So thank you for also staying on till now. And we want to say that as you leave here, wherever you're going, may God take you safely. It is goodbye. Our lunch is downstairs where we took the coffee break, where we had the coffee break. So we'll go downstairs and then we'll have our lunch packed for us. Thank you for making time, and see you another time. My name again is Reynolds of Ekwapong.